Bom dia a todos. I'm going to change to English. Welcome to workshop on game theory in honor of Marilda Sotomayor. This workshop is a satire event of the International Workshop on Game Theory and Economic Applications of the Game Theory Society that just finished this week there in São Paulo, the Universidade de São Paulo, with the presence of many distinguished researchers. And following the tradition of our school, Graduate School of Economics, in hosting meetings in economic theory, today we have a privilege of having a subgroup of these people here present their work. Thank you for their presence here. I'd like them to thank also our sponsor, Fundação Getúlio Vargas, EPGE, Instituto de Pesquisa Econômica Aplicada, and Economics and Politics Research Group to make this event possible. Just a briefing note, Professor Marilda, she's expected to be here around noon with Professor John Nash. They are coming from São Paulo because they stayed there too late yesterday, so they are able to be here just middle of the day. So now I'm going to pass the word to Professor Luis Araújo, our Vice Director of our school, to say a few words, and then the President of EPGE.
Thank you very much. And then it's very nice to see that how we've been able to, under diversity, to develop theory. This is a proof of that in Brazil, in particular FGV. Let's tell a little bit of the story of theory in Brazil, and in particular in FGV, Fundação Getúlio Vargas. The person that you're going to meet here later on, the current president, is Carlos Ivan Simonsen Leal. He has a PhD in game theory, just to give you an idea. But I go back and then think about his uncle, that was Mário Henrique Simonsen. And then we thank him a lot because he was a partial student in IMPA. There was being a strong relationship between Getúlio Vargas and IMPA. And he was a student in IMPA, and then he understood the importance of mathematics to economics, and then he dropped his academic career, although he was extremely bright. And then he was teaching here in Getúlio Vargas. He was the director of the position that Rubens Cisne has now. There's a lot of responsibility on us that following his tradition. He was the Minister of Finance, but he never left theory. He always, after being minister many years, he wrote a very good book in macro. But the mathematics was done much more carefully than all the international books, I must tell you. There is an international macroeconomics that you know, he did it better, more precision, projection in Hilbert space, and so forth. So it's a very, and he was the person I owe him a lot, because he was the person that invited me to teach Getúlio Vargas. Besides IMPA, I came first in IMPA. But that helped me a lot in my career. And then he always gave support to the development of theory, so and economics as a whole. And sorry about I hope you can hear it now. So, but this. We had some tradition. We cannot do in larger scale, because you can imagine Brazil is always competing for resource. So whenever you form, like in Siemens himself, there are many others that came later that end up doing very important practical things because there are few of us. But a small group remain, and this is a proof that to make this special event for Marilda, that I had the honor to be part of her thesis committee discussing the beginning of her research, not in matching, but dynamic economics, that was she originally interested. And I hope I want to welcome you too, and then to thank people who come from very distant and not only went to São Paulo, but even come to Rio. So, and to Getúlio Vargas. Welcome, everybody. Thank you.
Thank you, Aloysio. Now, the President of EPEA, Sergei Soares.
Well, good morning. First of all, I'd like to thank Fundação Getúlio Vargas for hosting this important workshop. I think it's a part of their immense, almost unmeasurable contribution to our country and to the development of economics and the development of our country. I'd also like to welcome all of you here. It's a true pleasure to be here welcoming you. I think that this workshop is part of another series of events that has come before, and I think it will be very useful and very helpful for everybody here. I'd like to congratulate the workshop and the organizers of the workshop in choosing Marilda as the special person in honor of whom this workshop is being made. I mean, her leadership in the academic world is immense. I think nobody will disagree with that. Actually, her leadership is so great that we had 4 Nobel Prize winners in the Congress on Game Theory that just ended at USP, John Nash, Robert Altman, Eric Mansky, and Alvin Roth. And I think that she is there's some people who in the development of a field, you almost come to identify that field with that person, and certainly Marilda is one of these people. I would also like to thank all of our distinguished visiting international scholars here, and it's important to say that none of them received a cent to be here. And I think it's very kind of you, and I'm very honored to be here with all of you. Before finishing, I'd just like to say something from my side as president of EPEA about the importance of linking theory, applied research, and more theoretical research. So it's not my area, but as far as I know, there's 3 areas in which game theory has had a lot of applied use, which would be matching, voting rules, and auctions. Here at Getúlio Vargas, there are excellent researchers such as Luiz Araújo and Paulo Klinger, who have worked on the more theoretical side of this. We at EPEA, we're the name of EPEA is the Institute for Applied Economic Research. That's what our name is, and that pretty much says what we do. I think there's many false divisions in economics, and one of these false divisions is between applied and theoretical. And we need more interaction between the two sides. And I think we need more interaction, for example, between EPEA and GV in game theory. Why do I say this? At EPEA, we have, for example, Danilo Coelho, who has been using things that were developed for voting rules in very practical, down-to-earth applications in institutions such as our prosecutor's office, Supreme Court, whose members are selected by the rule of K names. And so this is an example of how a very theoretical application becomes a very practical application. We have Alexandre Marinho, I don't see him here, I don't know if he's here, who has been working on better ways to do matching between organ donors and organ recipients for organ transplants. And once again, this is a very practical application of theoretical research. So I don't want to take up your time because I'm sure there's much more interesting people for you to listen to than me, but I think I would just like to leave this appeal that we need greater interaction between theoretical economics and applied economics in all areas, but in particular in game theory. So That's it, and thank you very much, and welcome all of you.
Thank you, Sergey. And now a few words of our chairman of our school, Escola Brasileira de Economia, Brasileira de Finanças, Economia.
Thank you, Humberto. Good morning to all of you. I want to start thanking those who took the charge of organizing this workshop, which is something very difficult to do. That starts with Humberto and Aloysio, and we also had the sponsorship of EPGE. This is a workshop which actually is a satellite of the International Workshop on Game Theory and Economic Applications of the Game Theory Society. And I would also like to thank besides EPGE, the EPRG, the Economics and Politics Research Group. I am very happy to notice that our school is somehow fulfilling its role, which is having people from all over the world come over here to interact with our faculty, with our students, and with our distinguished guests of several different places in Rio and in Brazil. In the last 2 weeks, I had here in this table discussions which I hope have been very fruitful to our students and to our faculty. We had José Manuel Duran Barroso telling us 2 weeks ago here in this table about the situation in the Ukraine. We had João Manuel Barroso telling us about why so many people were so wrong for such an amount of time regarding the euro, and now I'm talking about 2011, 12, and 13. And he said that when he was in a tour in the European banks and in North America as well, that almost the majority of people would predict that the euro would collapse in 2 or 3 months or 2 or 3 weeks, and that was during 2011, 12, and 13. And he also told us, and I hope our students have taken advantage of that, his role in climate change. He has been very active and told us the details about the 40% reduction of gases and 27% of renewable energy, which are the targets for Europe in the years to come. And last, I think 3 or 4 days ago, we had for the second time our friend, I can say he's already a friend of our school because he has been here twice with us, Eric Maskin, was also teaching us about why using majority rule should be superior to using some other rules, which would more easily allow to having the voter voting strategically. So I think you all know his ideas. And he was also suggesting regarding Brazil that could be a good idea. After that, some people were speculating about how that would apply to the Brazilian voting system. So somehow the discussion about a very important thing, which is politics, but it's complementary to the discussion about institutions, has permeated the school. And this is my role as the dean of the school, is having people come over here, taking care that things work properly. So I hope the way we have organized this workshop, our guests who came from so far away with such hectic agendas have a good time, not only here but in Rio by night, going to nice places that we have over here. This is the role which I have to fulfill, and I'm happy to see that these things are working very, very well and very properly. I have some words to say about the great and spectacular contribution of Marilda Sotomayor, but I reserve that for the other session in noon. And last, I'd like to thank once more a professor of mine, which I'm always very proud to say that Aloysio Araújo, who is here to my right, for the absolutely great contributions that he has given to our school, to our community, to Brazil, and mostly because sometimes you ask, can I make some difference in the world? Well, yes, I think everybody can, and Aloysio is an example of that. Thank you very much, all of you.
Thank you, Rubens. So now let's enjoy. Let's start the workshop. I'd like to invite Leandro Gorno, who's going to be the chair of the first session in the morning. He is one of the organizers of our workshop. Thank you.
So welcome everybody. So I'm very happy to be here, and I'm going to chair over the following two talks. So first, I'm delighted to introduce Salvador Barberá, is a professor of economics at the Autonomous University of Barcelona, and is going to present about sequential voting and agenda manipulation. Salvador.
Okay. Is it working? Okay. Very happy to be here. Thank you to the organizers and to everyone for being here. As Sergio Soares, let me say, I'm going to present this joint paper with Anke Gerber from the University of Hamburg. As you will see, it's on a very classical topic, on voting theory. As Sergio Soares said, game theory has a number of applications, and on some of them especially close to real life. And I will not claim that voting is more important than auctions or matching, but I can claim that the interest on voting and in game theoretical aspects of voting has a much longer tradition, and I will provide you proof of that in a second. It's also been mentioned that Eric Maskin was here last week talking about manipulability of methods. I'm not going to contradict him today, but I'm going to look at a different way to manipulate mechanisms. And because of that, I will also go back to the issue whether or not simple majority is superior or just non-comparable with other forms of qualified majorities, which are sometimes required rather than simple majority to make final social decisions. So, like any researchers know, contradicting is not the problem, is maybe looking things at different perspectives, and that's what we're going to do today. So, let me start by a proof that indeed game theoretic voting issues have been around for a while. This is part of a letter from Pliny the Younger in AD 105 to his mentor Afranius Dexter, in which he expresses his concern and doubts about whether he did or did not do a good job in the Senate when a case was presented. And the case was this one. The consul Afranius Dexter had been found dead. So it was not known whether he had killed himself or his servants were responsible. But in that case, it could have been that they had acted criminally or just followed the orders of his master. And the issue was what to do. If he had died, his servants should be freed without punishment. If they had followed his orders to help him die, they may have violated some moral law, but were not guilty of a big crime. They should be given a small punishment. If they had killed him, they should be put to death. And the Senate was divided roughly in three parts with equal opinions respecting one of these things. And he was fully aware that the way in which this question was presented would be decisive in terms of the outcome that would result. There was one way to present it in which they can vote for either of the three, and then obviously none of the three will get a majority, and then some internal coalition formation would go on. One way to, if not avoid that, to structure that voting method in a more systematic way would be to present the voters with binary decisions. First, they could decide on two options, and then on the third one. For example, they could say, are they guilty or not guilty? And if guilty, what punishment they deserve? Or they could say, should they be killed or not? And if not, what else do? No? Oh, no, that was the same one. Well, I could say, well, you can organize these things in the three different ways because of the order. And I will see formally how this is done. And we will also see that the order in which these options are presented is going to be very decisive in the final outcome. So, that's the topic we are going to cover. We are going to examine sequential voting rules in which at each instance individuals have to decide upon two possible ways of action. We are going to consider the strategic possibilities that is opens for a chair whose task, among others, is to decide on the order of vote. This has been studied thoroughly by the literature for the case where the decision is taken by simple majority. And we are going to introduce the possibility, in addition, that the decision whether to branch in one direction or the other of the voting system be made not necessarily by simple majority, but maybe by qualified majority. And we are going to examine in these cases what are the possibilities that the chairs find open to manipulate in that particular sense, not in the sense of misrepresenting their preferences, which was the direction in which Eric Maskin discussed yesterday and on which many of us, including me, have worked systematically, but on this different type of manipulation, the one that comes from the fact that you have control on the agenda, that you can decide on the order in which the decisions are taken, but not necessarily under simple majority, maybe also under other forms of majority. And that's what we are going to do, and we're going to do it for two particular types of ways in which the voting, the sequential voting can be organized. And these are the two most used methods, as we shall see, that are actually heavily studied for the workings of parliaments. Let me show you the difference between the two methods we are talking about for the case where there are three possible alternatives. The first method that we'll call the amendment procedure, and I'm going to do it very simply for three alternatives, is the one where you establish an order, say A, B, C. Now you first confront the first and second in this order, A versus B, and then whichever is favored in the initial vote is then confronted. I don't know if I have a pointer here. No, no, not the color. Well, okay. No. So, no. I'm using it. Don't worry. Okay, so you decide. No, don't touch. You decide between A and B, and then if B wins, you decide between B and C. If A wins, you decide between A and C. This is the amendment procedure. The other procedure is the successive procedure. Now you also have the order A, B, and C, but when confronting this decision, if A wins, it's already there. It's A. If A does not win, then you have to choose between B and C. And these two methods are different. In fact, the procedures that Plinius the Young discussed were more like the left, the one in your right, in which you could decide, well, should we kill these people, yes or no? And if not, what kind of alternative do we follow, a light sentence or a strong one? Or we could say, well, should we, declare them guilty or not guilty, and if so, what else to do, etc. Now, this is also, by the way, the structure of for those of you who know what's going on in Catalonia, my country, and in Spain, we have a referendum for November 7 that may or may not happen. So I'm talking about practical stuff. And the question is, may look funny to you, is, do you want Catalonia to be a state, yes or no? If you say no, that's A, that's it. If you say yes, then the question is, do you want this state to be independent, yes or no? And so you have three alternatives. You have no, yes, no, whatever this means, yes, yes, okay? So you see that both in the very distant past and in the very near future, these things are used, in fact. And they are used in many, many places. For example, they are used in the successive procedure in some form of another can be idealized as following these, as being followed in parliamentary practice in all these countries, and the amendment procedure in this other one. So the amendment procedure is more related to Anglo-Saxon tradition, the other is more to to continental European tradition, but both are heavily used. And, I'm a little bit worried to mention these things in front of Steve Brams, who knows so much about it. But as you will see, our contribution, hopefully, is one where what we depart is from majority voting, as I said. Okay, so here is the classical starting point for a lot of social choice theory, including Arrow's theorem, and is that when we have two alternatives, majority is a very amenable thing. No, either you have a majority, you don't have a majority. You have a simple majority, you don't have a simple majority. You have a qualified majority, you don't have a qualified majority. No ambiguity. When you have more than three alternatives, it can be that according to whatever majority concern we are serving, it could well be that when confronted pairwise, A is socially preferred to B, but B is socially preferred to C, and C is socially preferred to A. The problem with that in theoretical terms is that then what seems to be the natural definition of what should be chosen, which is whatever is socially preferred should be chosen, then stops having meaning, because there is no such thing that is socially preferred to everything else. And this is the classical Condorcet paradox, on which much of game theory, game theoretical aspects, but also normative aspects of social choice procedures takes a starting point. But let's see a little bit more carefully what can happen in that case. Let's start by the first of the methods, by the amendment procedure. And let's look at this case where A is preferred to B, B is preferred to C, C is preferred to A. If all individuals vote sincerely, just for a moment, forget about the possibility of being strategic. So let's previous to game theory, so to speak. If you have an order A, B, C, you would first vote for A and B. A would win, then you go to A and C wins. So the sincere outcome would be C. But if the order of presentation had been BCA, then between B and C first, you would choose B, and then between B and A, you choose A. And with the third case, you would choose B. Okay. So the order would completely determine the outcome if people voted sincerely. Now, would people vote sincerely or not? That's another concern. People may realize that, if they vote for A, then they go to this disjunctive A and C, and the end result is C. So they could have said, okay, at the beginning of the voting, they can do what's called backward induction. No? They can say, okay, what's the consequence of the vote of A between A and C? The consequence of the vote between A and C is C. What's the consequence of the vote between B and C? It's B. So actually, when I am called to vote between A and B, I'm not going to consider that I'm voting between A and B. I'm voting between something that leads to C and something that leads to B. So if I prefer B to C, I'm going to vote for B, even if I may like better A. Because voting for A is not voting for A, it's voting for C. And so the sophisticated outcome, which is in terms of game theory, the backward induction equilibrium of this game, is no longer C, which would be the sincere outcome, but B. The problem is that with the other order, if we do the sophisticated reasoning, backward induction reasoning, now we would get C. And with the other order, we would get A. So regardless whether individuals are all sophisticated or not, the order matters. And what we are going to do in this, what we're doing in this paper is to consider that people are sophisticated. And so we're looking at the sophisticated equilibria of these votes where people look, forward and realize that the consequences of voting between A and B in the first case or between B and C in the second case are not the straightforward thing, but they are actually, like in one case, voting between C and B, in the other case, voting between A and C, and so on. This is even more important because being straightforward in the other procedure is not even a clear thing. We have said that individuals may prefer A to B or B to C or so on. But here, when you confront this other method, you see that you're asked between A and not A. But not A is either B or C. So what is to be straightforward? So let's go directly to the sophisticated analysis. And in the sophisticated analysis, we can see that the outcome in the first case, if you prefer, if the order is A, and then if not A, then B and C, the outcome will be, well, look, if I say not A, I'm going to get either B or C, but between B and C, I'm going to get A. I'm going to get B, so between A and B, I'm choosing A. And in the second case, It's a similar reasoning. I'm voting between B, and the winner of AC is C. So then, between B and C, I vote for B, and so on. But the same phenomenon occurs. The order fully determines the outcome. I've done all this reasoning for the case of majority voting, and indeed, the case of majority voting is extremely well studied. There is a literature that I passed, but that is, I can go back to, if you wish, with full of authors that have fully satisfied all research concerns in this topic. Now, so this is the definition of the sophisticated outcome. Let me just point out the following. All that matters when analyzing these games, when there are not two alternatives, but any number of alternatives, then, is the social relation. You know, whether A is better than B socially or not. And this can come from the use of some rules. And the rules we are concentrating on is the rules that determine that X is socially better than Y if the number of individuals that prefer X to Y is greater than or equal to a certain number Q. When Q is half of the voters plus 1, that's simple majority. If it's larger, then this is qualified majority. If it's smaller, it's a less obvious type of rule, but you can also define it, and it would probably represent situations where a small active minority can put forward winning options. At any rate, notice that if we have an odd number of individuals, simple majority implies two important conditions on this social relation. One is completeness, meaning that either X will be preferred to Y or Y will be preferred to X, because one of the two will have a majority over the other for sure. Completeness. The other property is asymmetry. If I have a majority, or X has a majority over Y, then Y does not have a majority over X. The social relation satisfying these two properties, completeness and asymmetry, constitute what are called tournaments. And a tournament is a mathematical object that has been subject to enormous amount of study and literature. Where the main issue is that often a tournament does not necessarily have a clear idea of what is socially best, but then the tournament literature tries to analyze the different meanings in which we could qualify the idea of what is best for different applications. In our case, we are going to study things that you could call generalized tournaments or quasi-tournaments, because what we do is to realize that when you have, for example, a supermajority, it may well be that X does not have a supermajority with respect to Y, but Y does not have a supermajority over X either. In which case, the social relation is no longer complete. You don't know which one is better than the other either way. If you have, but on that case it will be asymmetric. If definitely one has a supermajority over the other, it won't be the case that the reverse is true. So we will have asymmetry without completeness. The alternative is if the quota is very small, you may have this small majority to hold in one direction and also even in the other, so you always have completeness. But then you may miss asymmetry because you may have that both hold at the same time. So this is our contribution to this literature, is to analyze these things that are no longer tournaments and to ask questions that have a very traditional flavor. The question would be, under these cases, when are there possibilities to manipulate by choosing the order? And in particular, could we say whether amendment procedure is more or less manipulable than the other procedure? And for each one of them, could we say that the majority size makes or doesn't make things more manipulable in one case or in another? So I don't know how much time I have, but I should maybe skip.
20 minutes.
I have 20 minutes.
Oh, sorry, 24 minutes.
Okay. So let me show you a little bit how we would compute the sophisticated outcome for an agenda. If we use the order x1, x2 to xm, what would the amendment procedure do? It's a rather complicated calculation, but we can define it in an inductive way. You know, you could say, well, if there were only two alternatives, we will choose the second one if the second one dominates the first. Otherwise, we stick with the first one. So you see, it gives a little advantage to the first one. In the case where they cannot be, you know, in one you need full domination to go, in the other only weak. And this is, we break ties by determining the order. So the order determines many things, but in particular, you know, the first comer has a slight advantage over the latecomer. Given that, then, what would be the outcome of the amendment procedure if we had defined what would be the outcome for a certain number m-1 of alternatives, and we had already that, then what would be the outcome in the case of m alternatives? Well, we could be define it like that. You know, our comparison would involve that if we have to decide between x1 and x2, we look forward, and we know that if we go to x1, then we'll go to the sequence x1, x3, etc., because we have eliminated 2. If we keep x2, then we'll go to the sequence x2, x3, xm, because we have eliminated 1. These sequences are one amount less, so we know that we can compare them. And then we'll decide to go in between x1 and x2, we will decide to go for x1, or let me say, we will decide in the bottom line to go for x2, if the sequence OX2, X3, XM gives us something that is socially preferred to the sequence X1, X3, XM, and vice versa. And for the successive procedure, the same type of technique can be used to define, but I will not spend much time on it. So let me advance that our idea of manipulation will be double, and I will come in a minute. One idea is, look, for certain preferences, I may find that the order doesn't matter. If the order doesn't matter, the chair cannot manipulate by the order, and that's the end of it. So we'll look for cases where this happens. When the order matters, the chair can choose. But then it becomes important to understand the latitude of the chair's choice. It's not the same to be able to obtain two alternatives only by changing the order of vote, than being able, for example, to choose any possible alternative, as it was in the case of 3 alternatives and the examples I gave you. So we're going to, in addition to this dichotomic decision whether you can at all affect by the order or not to, we are going to also go into the issue whether one procedure gives you larger opportunities for the chair or smaller ones, depending on the social preferences. Okay? So this is where we are heading to. But in order to head in that direction, it is first very important to be able to characterize for a given problem what would be the outcomes that one can reach by different possible orders of alternatives. Okay? So we shall denote by OAP the set of attainable alternatives under the amendment procedure given P. P would be the social relation, the one that tells us whether any alternative is or is not socially preferred to another. And here is the result. We say, as you see, we say let P be complete or asymmetric. Because I said that under a small quota, you had completeness but not asymmetry. Under a large quota, you have the reverse. Only with simple majority, you have both. This is the case that has been thoroughly studied. We want to extend it to the other cases where only one of the two properties holds. And this is our motivation, is the use of these qualified majority rules. So let P be complete or asymmetric. And what we want to know is whether X can be attained by some order. And we're going to say, well, in order to know whether X can be attained by some order, it has to be that if we look at X and then at the set Y of X of those alternatives that dominate it, for any of these Y's, there should be a Z that dominates Y, but does not dominate X. So you could say that, you know, you can think of X as the one that you want to come out. You can think of Y's as potential enemies of X that would win over X in a confrontation, in a direct confrontation. Then Z's are the enemies of Y, the ones that would eventually eliminate Z's. So the technique as we advance will be to say, well, X can come out even if it has enemies that could eliminate it. We can organize our vote in such a way that by the time that this comparison between X and Y comes out, the voter knows that it's not really a comparison between X and Y. It is a comparison between X and some Z that would have eliminated Y before. Okay? So that's the kind of contorted definition of X is attainable if for each Y that could dominate it, we have a Z that dominates the Y but not the X. And in addition, because the order is important, there exists a certain ordering of these Z's, let's say the friends, indirect friends of X, that would do the job, as we'll tell you. Okay? So this is a theorem, it's an if and only if. If X satisfies this thing, it may come out for some order, if not, not. So the idea of the proof I already gave you. Basically, the necessity is of the part of the proof is to say, look, if I have this, I need these enemies of Y because Y otherwise would win over X, and I need to use these things. I need them. The sufficiency is to say, if these conditions hold, here is the order I will follow in order to attain X, and look for this here we will follow different orders depending on whether the majority quota is high or low, or whether we have completeness or not. In one case, we'll put first all these z's, which are the enemies of y, in the late part of the sequence, then the y's, then the x, and then all these things that are neither enemies that have not appeared in my definition. In the case of asymmetry, what you see we do is we put x first. But this is just how we determine the order. In the successive procedure, the ideas are very similar, but a little bit more complicated, because now we have to decide on the complete or the asymmetric case are not identical in statement, but very similar. So in one case, but it's always the same, we have an x, we have its potential enemies, and then we need z's that kind of eliminate these potential enemies y's. What we require from them in that case is a little bit different. If it's complete, we require downstairs what is written in black, ZPY. If it's asymmetric, then what require what is in the first condition written in blue, not YPA, not YPZ. We do not longer require this additional condition that these things are not killed by X directly. And also, in terms of the orderings, we have things that are a little bit more complicated, but that I will not insist upon. But basically then, with these same ideas, necessity comes out, because we need these alternatives that will eliminate the enemies of our candidate outcome before this candidate outcome is confronted, or rather, alternatives that will not be taken as such when the time of vote comes, because by looking forward, you realize that if you take an alternative path to X, you are going to end up worse. And the order of vote is similar as the one I said before. In one case, the X comes after the things that are a little bit on the side. In the other case, it comes first. But here, before, instead of having Y's and Z's explicitly stated, we talk of W's, because it is rather tricky, and we have to select an order of these W's are both the X's, the Y's and the Z's, and we have to select a very delicate order in which to put them in order to finish. These are long proofs by induction, but that's our task to do, not today. So let me turn now to manipulability. When will it be that individuals cannot manipulate? When whatever the order is, the thing comes out. So it's very clear that if we have what we usually call a Condorcet winner in majority voting, it's one that is socially better than the others, then this one will come out no matter what. Okay? In this case, we have to be a little bit more delicate, because we have to say that it's something that dominates all others, but since we do not have one of the two properties that hold in tournaments, we have to be explicitly saying that these alternatives are such that X dominates Y and no other Y dominates it, okay? Explicitly. Otherwise, it would be implied. So in that case, it is clear that if one of these things exists, then it will win at some point any other thing that it's confronted to, and will be the end winner. The issue is, are there other more complicated situations in which I might get a single alternative by some choice of orders that even when there is no such Condorcet winner. And it took us a while, because in some cases it's clear, but in others it's a little bit more delicate. But yes, indeed, there are no other cases. Okay? So the only way in which you won't manipulate is if there exists one of these animals. In all other cases, you will have sets. So that's our first result. Given that once we don't have this generalized Condorcet winner, there will be opportunities to mention. So our first condition could say, or our first conclusion would be, from this strict view of manipulability by order fixing, both procedures are equally manipulable in this dichotomic sense, yes or no. Are they equally manipulable in the sense that they give the same amount of flexibility to the chair? No. In that case, we can, let me skip this one, I can come later. This is the result. For every P asymmetric or complete, we have that the set of possible attainable outcomes under the amendment procedure is never larger than the set of attainable outcomes for the sequential procedure. No. And not the other way around. So there may be cases where the outcomes are the same, the set of outcomes that you can attain, but if there are cases where one is larger than the other in the set containment, see, it will be, the smaller one will be the one associated with the amendment procedure. And going back to these conditions, here we have put together the conditions in blue. There are the conditions that we already described for the amendment procedure, and in blue for the sequential procedure, and in A for the amendment procedure in red. And an inspection of these conditions when putting them together will reveal, if we had more time, that the reason for our following theorem is that to become an outcome in the amendment procedure you have to satisfy more demanding requests. But the intuition is quite clear in the sense that, if you remember, in the amendment procedure, you have to beat everyone. In the other procedure, if you are first and win, you're done. So in that sense, it is less demanding. Okay, so this is our first conclusion when comparing this across these two procedures. I could go for this, but let me go to the other question. Is now let's look at the amendment procedure. Could I say under the amendment procedure that the choice of the quota makes a difference in terms of chair manipulability by choosing the order? Yes or no? If we only stick to the idea of one outcome non-manipulable, many outcomes manipulable, then I will not contradict Eric Maskin, although he was talking about another form of manipulation. And majority voting, like in many other situations, emerges as a special and especially favorable thing. In that case, it would maximize the number of profiles where there is no room for order manipulation. Okay? On the other hand, if we look at now, and the same is true, excuse me, and the same is true No, I'm now. So this I don't think I have here. Yeah, that's what is here. No. That's the other thing. So the one I'm going to say. What I told you is a new result that was not included here. No? So what I told you is, if we look at the dichotomy, simple majority emerges in both cases as the case where there is less manipulability. But if we don't look at this dichotomy and we say, okay, let's look now, when you can you manipulate toward a larger set in one case than in the other, yes or no? Then we have that, in general, you cannot say. So it could be that a large quota, and things are not nested in general. It could be that with a large quota, you get a small set, and then with a slightly smaller quota, you get another set, which is larger, and then you go back when you keep decreasing the quota, set that is smaller. So you cannot rank the majorities in terms of the size of the sets that they will provide to the chair as opportunities. You cannot rank them in general. You can only rank them in the particular case, not of the amendment procedure, but of the sequential elimination procedure there, where in that case, you know, for quotas that are larger than 1/2, then it is true that the larger quota provides more opportunities for manipulation. So in this restricted case of quotas between the simple majority and supermajority, in this case, yes, you can say that simple majority is in that second procedure provides less opportunities to manipulation than larger qualified majorities. But only in this case, not for small quotas, and not definitely in any case for the amendment procedure. So we have a lot of examples. Let me just say that it is been well known that 5, 2, 1, 0, 2. It's been well known that the amendment procedure will never give you Pareto-dominated alternatives, whereas the other procedure may provide in certain instances for the outcome to be even Pareto inferior. But so in that sense, and this was well known for the case of a simple majority, and it is still true for the other cases. But the result goes beyond, because it's not only Pareto versus non-Pareto outcomes that makes the difference in the sizes of the sets. You can also get things that are not Pareto dominated, but enter one of the sets, but not the other. So basically, this is our conclusion. There are two types of possible classifications. One is a dichotomic one. For this one, we have rather sharp results that these things look very similar in terms of manipulability and eventually favor simple majority. In the case where you want to go further and not only compare whether it's manipulable at all or not, but you want to qualify it by the size of the manipulations, then the comparisons are much less deterministic, etc. So back to Plinius. What happened to Plinius? What happened to Plinius is that he was presented with a sequential voting. I've been reading this text that was brilliantly elaborated upon by Robin Farquharson in a master's dissertation in the 60s. A brilliant paper which became a book, Theory of Voting, that I wholeheartedly recommend to you. Beautiful pictures. Pre-game theory, you know. And in my last reading, the guy argued that there was no reason to do this in sequence because sequences would generate advantages. And apparently he managed to get the three options to be on the table on an equal foot. And his concern at the end, when writing to his mentor, was, okay, I didn't get anything because then a coalition formed. And the outcome was the same, okay, as we would have expected from a proper sequential method. But of course, the coalitions that would form would be different, whereas in this, anyway. I hope this was at least entertaining and a proof that some of the things that we now do in game theory, as we know from also other literature, have been thoughtfully discussed by our long time predecessors, maybe not in these words, but with equal wisdom or lack of wisdom thereof. Okay, thank you.
Thank you very much. Now we have a few minutes for questions, if there are any.
Hello, I'm a graduation student from undergrad student from FGV at economics. I actually, you made me curious about one thing about what about if there's not perfect information on successive voting. That is, when someone wants to hedge their bets, voting for the one that will finish it instead of risking getting one that they might not want.
I think this is an absolutely legitimate question, and you catch me in a situation where I am talking about a topic in which it is absolutely legitimate. Let me say you that most of my life and my work has been on strategy proofness. Strategy proofness is a different type of property in which we also examine strategic issues, but not relating to the order in which we vote, but relating to whether or not when asked for our preferences, we do reveal them or not, which was in fact the kind of manipulation that Professor Maskin discussed, and on which I have invested most of my work. Now, in that other context, I'm not escaping your answer, I'm just giving prolegomena. In that other literature, I insisted very much on strategy proofness, because strategy proofness means that telling the truth, revealing your preferences, is a dominant strategy. Now, why was I so interested in it? Because if you have dominant strategies, I should be ashamed of saying that in a game theory place, but I will say it, then you can escape game theory. Don't worry about it. I mean, you have a dominant strategy. What else? You know? So that's for people like me who are only marginally game theorists, that's very safe. You know, you have a dominant strategy, you're happy. Of course, it is hard to get mechanisms with dominant strategies if you look for unrestricted domains, but there are many applications, including voting under single peak preferences, including matching models, including many other things, where it is possible to define strategy-proof mechanisms for those restricted domains which are induced by natural economic considerations. So my sympathy goes for strategy-proofness because it does not require anyone to bother about game theory. Now, in this particular case, I happen to bother about game theory because our considerations where in fact, if you think of it, these guys, I never said what was a good strategy for one of these chairs. I just said, you know, this is no longer a game theoretic problem either. I mean, the game theory was in the analysis of what was attainable. But once you know what is attainable, this guy is no longer facing a game. He's facing the uncertainty maybe of whether or not he or she will be the chair. But once he's the chair, it's a decision problem. I choose whatever is best out of this menu that is available to me by the orders. Okay? So in that context, I think my answer to your thing is that all the difficulty in resolving your difficulty lays in the careful analysis of these sequential choices according to some game theoretic concept that either well established or to be established. No? So then what we have done is to take the view of complete information, right? If you don't want to do it with complete information, I wish you luck and strength. I think it's an excellent project, but then what you should do is to look at an alternative characterization of what behavior and consequences you could expect from the game that you would define under, you know, maybe partial information, no information at all. You may revert under certain assumptions to a position where you then can think that under complete lack of information, maybe a reasonable thing is to tell the truth after all, because these being monotonic mechanisms, you know, either you lose or win, but on the average, you'll probably win more than lose by telling the truth. But all these would have to be formalized, put into game theoretic terms, and then once the set of attainable equilibria would be, then you would revert back to what we have done. But I think it's an excellent question and a challenging project.
Okay, we may have like one more short question, if there is any.
What happened to the servants?
I think they were given a light sentence, but either Plinius was too worried about the, or maybe they have put to death because he was very anguished in the letter. But I was anguished enough with the problem that I didn't finish the last lines in my last reading, and once know, but I do not know now. Sorry, but it's you know, let me put it this way for people who are not necessarily theorists. It's such a thrill to understand that these people were so sophisticated and not only acted strategically, but reflected on the strategical aspects. That I think that if you have spare time and go to a wonderful book that I can recommend, which is called, it's by Hurkens, and it's the history of, it's about the history of social choice. It's readings on early social choice. I have to tell you, that's for chapter 1. Chapter 2 are 2 papers, if I can call them so, two writings by Ramon Llull from Mallorca, philosopher, 12th century, early 13th century. In one of them, he describes very, very convincingly the Condorcet winner. In the other, he describes very convincingly the board account. Where does he apply it? To the choice of abbots and abbesses in monasteries. Does he speak about manipulation? No. explicitly not. But he requires people to confess before going there, because their voting is going to reflect the will of God as to who will be. And this directly connects with what we know today about the Condorcet jury theorem, which is choosing the right guy or the right sentence. And in addition, for my absolute pleasure, he wrote one of these essays in Latin and the other in Catalan. So what else can I expect?
Thank you very much, Salvador. So we will now have a coffee break, and we'll be back 11:25. Oh, perfect.
Ela me deu uma disposição de cabelo que eu até paguei.
Dá pra subir mais ele?
Tá.
Acho que não tá pegando a mão.
Não, é só porque eu não alcançava.
Peraí. Ah, tem mais um. Está certinho.
Tá. Tá. Cadê? Tá. Ele tá vendo lá.
Pode falar.
Não. Aqui é ordem de importância. Eu vou botar outra mesa. E é no caso com 3. É na mesa 3, crianças no meio. Estou com deve ser. Depois eu sempre no meio. Eu pensei que ele é mais importante. Exatamente. E aí, deixa eu tava assim. Esse tava assim. 2. 2. Como a gente sempre faz. A FGV só paga faturado.
No WhatsApp, cara. De 3G. É o WhatsApp que eu quero. Gravar vídeo. Bota aí. Trabalhei na
Can I take this off? Okay.
Esse papo aqui. Oi? Gente, mas assim fica muito difícil. Olha só, olha só. Coloca os números, quem é? Era isso que eu ia fazer.
Fui a ver una serie de Marilda. Ahora con Neyman. Yes. I have some. So I will. Here,
Now.
Localization. Probably we're going to start like this. I'm sorry. First task that it is complicated because they typically don't go so if you want the job, I think I know it. It's the interest of maintaining the and I still not finish. Break and then 30 start with the session.
Estou esperando aqui. Boa tarde.
Okay, welcome back. So first, let me apologize for the delay on the coffee. And also let me explain that we are going to make a slight change because we are having a problem with the session we organized in honor of Professor Sotomayor. We are one person short of producing Professor Sotomayor because they are in a flight that is delayed from Sao Paulo. So instead of that, we are going to move forward the lecture by Professor Abraham Neyman after the next speaker. So now I'm delighted to present Stephen Brams, who is Professor of Politics at NYU, and he's going to talk about game theory and the humanities. Professor Brams.
Thank you very much. I'm very pleased to be here to honor Marilda. I considered talking about current research, and that could have been on voting or fair division or international security. But I was advised that perhaps another topic, more unusual applications of game theory, would be of interest. And since 3 years ago, I wrote a book called Game Theory and Humanities. That seemed an appropriate, less technical talk and subject for me to discuss. So what I'm going to try to do is give you an overview of some of the work done in the book. I actually have a copy of the book with me, and I'll pass it around. And I'm not going to be able to give very much detail, so what we have done is copy some of the figures in the book of the simpler games. There are some more complicated models in the book, and I'll go through them rather quickly just to give you an idea of the kinds of applications which I consider not only unusual but very interesting in the classical humanities. By that I mean literature, history, philosophy, theology, and the law. So I'm going to take examples from all of these. But before I begin, let me give you an idea of what I'm trying to do and illustrate this with a story from the Hebrew Bible. In the Hebrew Bible, one of the most famous stories, the so-called Akedah, is what happens when God commands Abraham to sacrifice his son Isaac, his only son. And what the Bible reports is that Abraham prepared his son for sacrifice. And in the end, he did not sacrifice his son because an angel intervened and prevented his knife from killing Isaac. So many religious interpretations of this story say that this obviously demonstrated that Abraham was a faithful servant of God, would even go so far as to sacrifice his only son. But a more strategic interpretation, an alternative hypothesis, is that Abraham could surmise that this was only a test, and God would not allow him to kill his son Isaac, which indeed occurred. And there's some evidence in the Bible that Abraham was not above such calculation. He tried to pass off his wife Sarah as his sister, so a Pharaoh would not kill him at the time. But more important, Abraham had been promised by God to found a great nation and have multitudinous descendants. So how could that happen if he sacrificed his only son? So this is an example, in my opinion, where strategic calculations were made by Abraham that he could go through the motions of sacrificing his son Isaac, but not worry too much that he would actually have to carry out the sacrifice. So these are the kinds of stories that I'm going to try to relate to game theories. Some pretty simple game theory, but I think not entirely obvious. The title is in Portuguese because I previously talked about this subject in Brazil, but you don't have to worry about my talking Portuguese. We'll go to the next slide and begin with another Bible story. So can we go to the next slide? Oh, this is it. Oh, okay. Sorry, I didn't see that. Okay, so this might not be so clear. So let me explain. There's another well-known story in the Bible about the conflict between Samson and Delilah. Delilah is this beautiful woman who Samson, a man of great strength, hankers after. Not the first woman whom Samson had tried to attract. The problem is that Delilah is in cahoots with the Philistines, who would like to kill or at least impede Samson, who was this great warrior, a person of great strength, and nobody quite knew where he had this strength from. So Delilah has a choice of either nagging or not nagging Samson for the secret of his strength, and Samson has the option of telling or not telling the secret of his strength, which turns out to be his long hair. He gives answers which are not correct in the beginning about the source of his strength, but after the third try, he does admit that it's his long hair that gives him this great strength. And the Philistines capture him, cut his hair, and then the consequences are pretty bad for Samson because he's mutilated. In the end, he gets his revenge because he's placed between two pillars of the stadium. His hair has grown back, and he pushes them apart and kills 3,000 Philistines by doing so, but he kills himself as well. So Delilah has good reason to try to extract information from Samson, and Samson has good reason to try to withhold it. But he, in the end, is not successful. So what I indicate in this figure is the payoffs. Now I assume only ordinal payoffs. The players only rank outcomes from best to worst. 4 is best, 3 is next best, 2 is next worst, and 1 is worst. So the higher the number, the greater the payoff. But don't attach any utility as such to these payoffs. It's just a ranking. So if you look at this payoff matrix at the top, if Delilah does not nag Samson, she's going to be unhappy, so she gets her next worst payoff of 2. Samson, because he's unforthcoming, he doesn't tell the secret, and he's not nagged, is very happy. He gets his best payoff of 4. On the other hand, if he tells a secret, Delilah will be happy. Samson's forthcoming, but now this is a reversal of roles, so Delilah gets her best outcome, and Samson his next worst. If we go to the strategy of nagging Samson, this is a bad outcome for both players, a mutually worst outcome of 1-1, because Delilah is frustrated. Samson hasn't revealed the secret of his strength, and Samson's harassed by the woman he loves. Finally, over here, if she nags him and she eventually gets him to tell a secret, which he does in the story, as I said, she's persuasive, but she had to go through some effort. So this isn't her best payoff. This is her next best payoff. And so Samson's reluctant. He sees risks, but he doesn't quite anticipate the consequences. So this is kind of the next best payoff of both before what actually happened occurred. So how do we explain this? The problem that standard game theory has is that the upper left outcome is a Nash equilibrium outcome. So neither player would have an incentive to move from this outcome. But I argue, based on some earlier work, a book called Theory of Moves, published by Cambridge in 1994, that we can justify Delilah's going from don't nag to nag, even though it's a terrible outcome for both players, because she anticipates that in the end, Samson will give in and tell his secret and move here. To argue this outcome in game theoretic terms, I postulate in Theory of Moves that players don't choose strategies simultaneously, the standard assumption of the normal form or strategic form of a game. They start at outcomes, which I call states, because they may only be temporary. And you consider moves and counter moves from the state. And then you do what we call backward induction. If there's a move here, a counter move here, possibly a counter move, you reason backwards and try to determine where, starting from a state like this, you'll end up. And the argument is that in this particular case, it would be a move here. Delilah nags Samson. Samson tells his secret. Now, it wouldn't go on because even though Delilah would do better going back to not nagging, Samson could move back to the beginning. So I start the backward induction argument assuming a move, counter move, counter move, and counter move as possible. And on that basis, I can argue that there would be a move from the Nash equilibrium outcome here to here, and then play would stop. So that's how I argue it was rational for Delilah to nag Samson, and eventually for Samson to tell the secret of his strength. Any questions? Oops, what did I do? Oops. Sorry. Okay. So here's another conflict between sexes. This is based on the Greek tragedy, actually it's both comic and tragic, play called Lysistrata. And in Lysistrata, the women, led by Lysistrata, go on a sex strike against the men. They refrain from sex. So their choice is to refrain from having sex and not refrain. And the men, in this particular historical period, have the choice of fighting wars and not fighting wars. And at those times, this is ancient Greece, men preferred to fight than not fight. And the women were desolate. They were abandoned and very upset. So this is a quite bad outcome for the women when they don't refrain and the men are off fighting wars. It's the best outcome for the men. As I said, they really like to fight at those times. What Lysistrata does is rally the women to abandon sex, which is a frustrating outcome for everybody. It's frustrating for the women because the men are still off fighting, but it's also frustrating for the men. But this explosion that she creates induces the men to consider coming home from war, not fighting. This would be a partial success for the women, not a complete success because they're still not enjoying sex. It's a disaster for the men because they're losing in both counts. They're not fighting and they're not having sex. So now there's an incentive to move down here. And that's what actually happens in the play. And Lysistrata is ultimately successful. Again, we start at a Nash equilibrium outcome, which normally would be stable. Neither player has an incentive to move. The women don't have an incentive to move from 2 to 1, their worst outcome, and the men certainly don't have an incentive to move from their best outcome. But by escalating the conflict, by refraining from sex, Lysistrata is successful in inducing from this bad outcome for the men to come home from war, and eventually the women agree to resume sex. Pardon me? Oh, yes, it's a play. And a film, too. And a film. Okay, I haven't seen the film. I've seen the play. Okay. This is a theological game I discuss, and this is whether you should believe in God or, as I say, a superior being, SB. Incidentally, it's purely coincidental that those are my initials. Who plays against an ordinary person, P. And SB has a choice of revealing itself, but that would establish its existence. I'm going to say its, not he or she, or not revealing itself and not establishing its existence. And the person has a choice of believing in SB's existence or not believing in SB's existence. So if we go through quickly these choices, I associate payoffs with them, but instead of just making an argument that these are the best, next best, and so on payoffs, I do this lexicographically, which means I postulate a primary goal for each player and a secondary goal. So the primary goal for SB is he wants P to believe in his or her existence. And that's an overwhelming theme throughout the Bible. That if God wants anything, he wants belief in his existence, particularly by his chosen people, the Israelites. So that means that his two best outcomes, going back to his, 3 and 4, are associated with the person's believing, and his two worst are associated with non-belief. But to break the tie between two best and two worst, I assume that SB prefers not to reveal itself. The reason is, if SB revealed itself, there would not be a test of faith. And this should be a test, so that you believe without evidence. And similarly, I have secondary and primary goals for P. P wants belief or non-belief in SB's existence confirmed by evidence, or lack thereof. So P's two best outcomes, 4 and 3, are associated with there being evidence, revelation, and therefore a good reason to believe, or non-revelation, and a good reason not to believe. So this is an agnostic of a scientific bent. He wants evidence or the lack thereof. And the secondary goal to break the tie between the two best and the two worst is that P prefers to believe in SB's existence. So he's willing to give SB the benefit of the doubt. Well, what do we have here? We have a Nash equilibrium outcome, which is next worst for both players. That's a prediction of standard game theory. That's worse for both players than belief with revelation. So there's a problem here. It's akin to the problem in a famous game called Prisoner's Dilemma. But on the other hand, there are two what I call non-myopic equilibria. When you think ahead and do the backward induction calculation, it depends on where you start. And these are the two possibilities of ending up if you're farsighted. And I'm not going to go into details, but it gets you out of this particular equilibrium. And I think what we observe through the ages are periods in which there's belief without evidence, and then there are ages in which a more scientific view, the Enlightenment period, for example, people demand evidence. And what I would argue is that this game cycles over the ages. So we go through periods of religious revival and religious decline. And there's a kind of basic instability indicated by the arrows. So, for example, from this good outcome for both players, there's an incentive for SB not to reveal itself, and then an incentive, therefore, not to believe. And then if we go up here, this is a very bad outcome, but if the if SB wants to induce the better outcome, it should reveal itself, and then they'll have belief again. So that's the kind of instability in this game, I argue, actually occurs over the ages. Oops. No. This is, yeah. Okay, this is, wait a minute, I must have skipped ahead. Okay, so then now we're at a, oh, I see, okay. Yeah, I think it's a little better to point. Okay, so this is Shakespeare's play Macbeth, and I pick up the action early in the play. The conflict between Lady Macbeth and Macbeth. You might remember, if you've read the play, that three weird sisters indicate to Macbeth that he might be the future king. And Lady Macbeth is even more excited by that prospect. And they invite the king to visit their castle. And at that particular point, Macbeth has doubts. Should he really kill the king in his own castle? And then Lady Macbeth comes into the picture, and she takes a very firm stance that we planned this particular murder, it should be carried out. So she has a choice between inciting Macbeth to murder King Duncan or not inciting him to murder King Duncan, and Macbeth has the option of being an accessory to the crime or not. And we start off where there's no incitement and Macbeth is not going to kill. So Lady Macbeth gets very upset by that fact. She, as I said, is more ambitious than Macbeth, her husband, and she makes her famous "Unsex me" speech. She says, "Come, you spirits that tend on mortal thoughts, unsex me here, and fill me from the crown to the toe top full of direst cruelty. Make thick my blood, and stop up access and passage to remorse, that no compunctious visitings of nature shake my fell spirit. That no compunctious visitings of nature shake my fell spirit." And then a few lines later she says, "Come thick night, and pall thee in the dunnest smoke of hell, that my keen knife see not the wound it makes." I know I missed my profession. I should have been an actor. I did have the lead in my senior play, but it went downhill afterwards, so I became an academic. Okay, so let's look at this game. We start out here. Again, we have a Nash equilibrium outcome. So standard game theory predicts it stable. But I argue that Lady Macbeth, given her willfulness, has good reason to escalate the conflict and incite Macbeth, even accusing him of cowardice, unmanliness, to go from not kill, because as soon as she starts the incitement, this is a bad outcome for both, a terrible outcome for both, and then a rather weak figure that he is, he eventually goes along and they kill King Duncan. And this is actually quite a good outcome for both players in the beginning, but then if you read the rest of the play, things unravel more quickly, and everybody dies in the end. It's a tragedy. Oh, I keep going back. Why do I go back? Okay, now we switch to politics, and we look at the U.S. Civil War. And that happened in the early 1860s, and it was a conflict between the Union, the North for the most part, and the Confederacy, the South. And here I have generic strategies of compromising or not compromising, on the issue of slavery, the overwhelming issue in American politics from the 1820s to the 1860s. There were compromises reached in the 1820s, even into the 1850s. But by the 1860s, this became an irreparable conflict, and the South, the Confederacy, attacked the North at Fort Sumter, South Carolina. And they won early victories. The problem in explaining why that happened is the South was vastly inferior in terms of resources. Why would it attack the North? Knowing that in a prolonged war it would win. But it was hoping that it wouldn't be a prolonged war, and that these early victories would convince the North that it would be a terrible mistake to fight to the end against slavery. And maybe the North would negotiate, and the slave states would stay as they are. They might secede from the Union, and that would satisfy them. What they did is underestimate the doggedness of Lincoln, Abraham Lincoln, to pursue a fight to the very end. So this became the bloodiest war in American history, 700,000 deaths, more than in either World War I or World War II. And the population was a fraction of what it was in 1860. So how do we explain this war? So the argument is that this is a bad outcome. It persisted for 4 years. I argue that if the Union submits, this would be a terrible outcome for the Union and the best outcome for the Confederacy. This is almost the opposite. It wouldn't be such a bad outcome for the Union. Well, the comparison is this is a bad outcome for the Confederacy. This is a worse outcome for the Union. This is a Nash equilibrium outcome, so it predicts that the Confederacy should have submitted, knowing the strength of the North, but it did not. So, in my opinion, what happens here is that the strategy of the South fails because Lincoln persists. And even though game theory does not usually predict outcomes that are terrible for both sides, this is why the Civil War ensued to the very end. Back again. Keep going. Okay. So I think this probably is a familiar story to many of you. It's Shakespeare's Hamlet, another Shakespearean play. And this is particularly interesting because the normal explanation for what happens in the play is that Hamlet, who suspects that his uncle killed his father, poisoned his father, and then quickly married his mother, but he doesn't have evidence. And usually the interpretation is that he was this vacillating, indecisive character who couldn't make up his mind. My interpretation is that Hamlet was very strategic, but he didn't have the goods. He didn't have sufficient evidence that Claudius was a murderer of his father. So what happens in the play is there's a play within the play. And in the play within the play, the murder is reenacted. And Claudius is in the audience, is very embarrassed, angry, walks out, and then finally Hamlet has the evidence that almost surely Claudius murdered his father. So he goes after Claudius, but Claudius knows that Hamlet is now understanding that he is a murderer, and Claudius goes after Hamlet, and in the end, of course, both die. Everybody dies. So Hamlet has a choice of revealing or not revealing that he knows Claudius is the murderer of his father, and Claudius has the choice of killing or not killing Hamlet, or trying to kill or not kill Hamlet. And if there's non-revelation, it's a kind of failure for Hamlet if Claudius kills him. If there's non-revelation and he doesn't kill, this is dishonor for Hamlet because he didn't act when he should act. This is success for Hamlet if he reveals and then Claudius doesn't do anything, but Claudius does something, and we end up here. And that's actually the Nash equilibrium outcome in this game, as well as the non-myopic. So when players think ahead, they would go to the Nash equilibrium in this game, unlike some of the earlier games. So that's my explanation for the strategic interpretation of Hamlet, in which I interpret as basically a stalking game between Hamlet and Claudius. Each is stalking the other and trying to figure out when to act. And when both act, they both die. Okay, this is the Cuban Missile Crisis of October 1962, in which the United States discovered that the Soviet Union had placed intermediate range and medium range missiles in Cuba, nuclear missiles in Cuba, and demanded that they be withdrawn, and put up a blockade around Cuba, a naval blockade, which was euphemistically called a quarantine at the time. But the United States considered escalating the conflict to an airstrike. The problem was that the U.S. Air Force estimated the probability that it would be successful to be about 90%, which wasn't 100%, which means some missiles could have been shot and hit the southern part of the United States. And the common interpretation of this game is that it was a game of chicken. And in chicken, there's a compromise outcome, which eventually the two sides reached. But then there's a mutually worst outcome, which is commonly interpreted to be nuclear war. What's wrong with this interpretation is that even President Kennedy at the time estimated the probability of war, not even nuclear war, to be between 1/3 and 1/2. So it's not a certainty that there would be nuclear war, and therefore a mutually worst outcome. And here, the United States wins, the Soviets lose. Here, the opposite. These are the Nash equilibrium outcomes. There's also a mixed strategy Nash equilibrium in this game. And what we don't explain is how the compromise was reached. Now, it is a non-myopic equilibrium in the game of chicken, but I think the better representation of this game is the following. In this game, same strategies: blockade, airstrike, withdrawal of the missiles, maintenance of the missiles. This I interpret as a U.S. victory and U.S. capitulation, so this is even a worse outcome than in chicken. It's not 2-4, it's 1-4. This is not a 4-2 outcome, this is a 2-2, because if the United States escalated the airstrike, and the Soviets were in the process of withdrawing their missiles anyway, this would be a dishonorable U.S. action. The Soviets would be thwarted, but it would be a sneak attack, like the Japanese on Pearl Harbor. In fact, Bobby Kennedy, the Attorney General advisor to President Kennedy at the time, and his brother, said this would be a Pearl Harbor in reverse, blackening the name of the United States in the annals of history. So, of course, it's bad for the Soviet Union, but it's also bad for the United States. On the other hand, this would be an honorable U.S. action, because if the Soviets continued to maintain the missiles, we would be justified in escalating to airstrike. Now, it turns out that so we still have the compromise outcome in this game. It's a unique non-myopic equilibrium wherever you start, and that means that we now have justification for this as the outcome, and that's the outcome that actually occurred after 13 days of negotiation, mostly secret, between the Soviet Union and the United States. And the Soviet Union withdrew their missiles from Cuba after the 13 days, and the United States lifted the blockade. Okay, how many of you have read the novel Catch-22? Anybody? This was a famous novel of the 1960s. It actually was published in 1961. and it describes the experience of a combat pilot whose name is Yossarian during World War II, flying missions in Italy. And he's trying to get off flying duty, and he has to, in order to do so, speak to a psychiatrist to be relieved from combat duty. And the psychiatrist's name is Dr. Danica, and he can judge Yossarian insane, and then he's off from duty, or he can judge him sane. And Yossarian has to decide whether to ask or not ask to be relieved. But if he asks, he's obviously sane. And therefore, it's a bad outcome for Dr. Danica when he asks to judge him insane, because he has to do a lot of paperwork, and that's bothersome to Dr. Danica. If he judges him insane, it's a dishonorable outcome for Yossarian, because he'd be deserting his buddies to get off combat duty. On the other hand, if he doesn't ask, he could be judged insane. Then he would have combat duty and insanity, but he would show no heroism. And finally, if he's judged sane and he doesn't ask, he'd have combat duty and sanity. So I have payoffs associated with these different outcomes. And what's interesting about this game is it cycles 1 to 2. So Dr. Danica has an incentive to depart from 1 to 2. Yossarian has an incentive to depart from 1 to 3, 3 to 4, and 2 to 4. So that's why this game cycles. And the only way to induce an outcome is what I call moving power. So this game is kind of played over and over again. And if one player has moving power, as I define it, it can continue moving when the other player has to stop. So the double arrows indicate that the psychiatrist has moving power. He always can move down or move up. And then Yossarian would have to decide where to stop. And the choice would be between 3-3 and 1-4. And 3-3 for Yossarian is better than 1-4, so that's where he would stop. What actually happens in the novel is that Yossarian decides this is a stupid game, he's not going to win, and what he does is go AWOL, absent without leave, and decides, in effect, not to play the game. And a catch-22, which is now part of English vocabulary, and I think international vocabulary, is essentially a situation in which you're damned if you do and you're damned if you don't. It's a very frustrating situation. So what I'm trying to do in the novel is show that it actually can be analyzed using this kind of theory. Finally, let me go to a more serious application of a catch-22. Whoops. Why am I having so many problems with this? Oh, sorry. This game came up. And this is the Iran hostage crisis of 1979-1980. It's very small. I know you can't read it so well, but let me just try to show how you can introduce incomplete information using this theory. So this was a game played between President Carter and Ayatollah Khomeini, who displaced the Shah of Iran after the revolution. And Carter has a choice between negotiating or intervening militarily to try to rescue the hostages. And Khomeini has a choice also of negotiating or obstructing negotiations. And basically the message of this is that there was a real game and there was a game as misperceived by Carter. So the game as misperceived by Carter is the top game. The real game is the second game, and misperceived means that he misperceived Khomeini's preferences. So he thought that it would be next best if there were a compromise outcome, but in fact, it's next worst for Khomeini. So the consequence is that you have these two non-myopic equilibria in the game that was misperceived. Carter thought he could induce this, but in the real game, there's only one, and that's where Khomeini obstructs, even though Carter tries to negotiate. Eventually, Carter orders a mission to try to rescue the hostages. It's aborted at the last minute. The hostages are never released. And only when President Reagan is inaugurated in January of 1980, the hostages released, a new president, a new regime. Okay, so this is the application of a catch-22 game, which I actually make a generic kind of game, which is to say it's a whole class of games, and this is a different one from the game played in the novel, but it still qualifies as a frustrating situation. It's frustrating because the situation is one in which women were accused of witchcraft. This also happened in the United States, in New England, but it was more serious in medieval Europe, where reputedly about 100,000 witches were executed. Mostly women, about 2/3 were women. And the primary goal of the accusers was to confiscate the property of the witches, the accused witches. So the accusers have their choice of torturing or not torturing the accused witches, and the accused witch has the choice of confessing or not confessing her alleged crime. Of course, it was not, for the most part, a true crime. And I'm particularly interested in the outcomes for the accused witch. So if the accusers torture the witch, the accusers actually break the law by torturing after a confession. So even in medieval times, it was verboten to extract a confession under duress through torture. So this would actually be a bad outcome for the accusers if she confessed when they were tortured, when she was tortured. On the other hand, this would be an honorable death when she doesn't confess despite being tortured. This is acquittal when there's no torture and she doesn't confess. And finally, this is a dishonorable death where the accusers don't torture, but she confesses anyway. And for the most part, this did not occur because not only did the torturers want to confiscate the alleged witch's property, but they wanted her to implicate other people. And it would be dishonorable to, without torture, confess and implicate other people. So, again, I use moving power, moving around and around, because if the torture was carried out and there was a confession, this was not sufficient. So the torture had to begin again or be threatened again. And finally, for the most part, these confessions were extracted. So that's an idea of how one, I think, may use game theory, or this theory of moves, which I mentioned earlier, to understand the thinking of people, particularly human decision makers. Game theory is used in evolutionary biology and other fields where I think people do not, or animals, non-human animals for the most part, do not, as far as we know, think ahead. But human beings think ahead. And therefore, I think it's useful to define an equilibrium concept in which you allow for that with specific rules. And it seems to explain quite well outcomes in many of these situations. When people do think ahead, estimate the consequences of actions and reactions and so on, and I think give a new view of what is going on. Now, you can say that some of the actions are irrational. For example, the Civil War in the 1860s, which was so devastating. But sometimes these outcomes occur in difficult games. Also, I think what one can get out of the humanities is ideas that go beyond simple preferences. It seems to me that one common accusation against game theory is that Well, it can't deal with emotions. It can't deal with feelings like anger or jealousy or even love. Well, in my opinion, these emotions are often quite rational, and they show commitment, for example. And under those circumstances, they should be part of the game. For example, my quotation from Lady Macbeth, where she steels herself for the murder of King Duncan. That's a very strong emotion, which I think can be interpreted as a strong preference. And it forces Macbeth in the end to go along with this woman who's not going to compromise. I think I better stop there. I'm probably about out of time. Thank you very much.
Thank you. So now we have a few minutes for questions.
First of all, thank you for your speech. It's very interesting, and congratulations. I'm Russian, and my question will be about Crimea crisis. I just want to know your opinion, maybe your think about what is the best outcome for Crimea in this crisis? Was their best decision or not, as for you?
I'm not capable of answering that question.
No, and just as their theory, is it to...
Well, to apply the theory, it seems to me, one would have to set up the game. Even a simple game like a 2x2 game requires a lot of thought and justification. And if the game is more complicated and each player is having two strategies, then the big game becomes larger and more difficult to analyze using this kind of theory. So I think I cannot give you a top-of-the-head answer on that one. Sorry.
Thank you anyway.
Okay.
Thanks.
There was another question there.
Yes.
Fantastic speech. Could you perhaps dare to use one of your slides to discuss the Ukraine situation?
That's the same kind of question I just...
Sorry, I was
Okay.
Any other question?
Just a clarification.
Please wait for the microphone.
Sorry, just a clarification about this last game, where the torture in this case would not torture to death. The execution would come afterwards, or is the torture? It's either you are tortured to death or confess, or just.
Yeah, I mean the usual choice that these accused witches have was to try to endure torture, and a few did survive. A few were tortured and refused to confess, and even after several tries, did not confess. And that's why we have documentation of this from medieval sources. But for the most part, it was a catch-22. If you didn't confess, you were tortured, and eventually you did confess. If you confessed, then they had the goods on you, and you were probably killed anyway. So that's why it was a very frustrating situation.
For the purpose of this game, you assume they don't confess in the initial state, and if you are tortured, you confess.
For the most part. For the most part. Yeah. Yes.
Thank you. So before the next talk, let me repeat for some of you that may not be here, we are doing a slight change in the program because Professor Sotomayor and Professor Nash are in a plane that is delayed. So now we are going to move forward the lecture by Professor Abraham Neyman, Professor of Economics from Hebrew University. Professor Neyman.
Is this? Okay, it's a great pleasure to speak here, and I'm sorry for you that instead of watching now the beautiful girl and the beautiful mind, you have to watch me and listen to this talk. And I'll try in the course of this talk to tell you a little about what I'm doing. I assume that not the mathematical background of not all of you is sufficiently high to go into the details, or even if it is, that you are already tired. And I'll try to do the mathematics as low as possible, or just to touch the main points. And I would like to say that at the end of the talk, I will pose a problem that if somebody solves it, provides a positive answer, I would invite him to a dinner in any place of his choice, including a business class ticket. And if it will be solved with a negative answer, will prove that some conjecture is not true, only the dinner at a place of his choice.
So, I want to bargain some more. How many co-authors can one bring?
They will have to flip. Okay, they could share the business class ticket with two economy tickets. Okay. So the topic is continuous time stochastic game. Yes. So the topic, the title is continuous time stochastic games. And I would like to tell you about myself. I am very much interested in what's going in the real world, including soccer, including financial crisis. And I know that it's a painful topic to mention here, but I'll mention it a few times. And so I'm interested in these topics, and at the same time, in the background, I'm trying to think what will be the corresponding game theoretic model that will enable us to tackle this type of topics. So let me give you two motivating examples. The first one is the financial crisis. So first of all, if you look on each financial crisis, it had been forecasted by many economists. Many other experts claim just before it's happening that this time is different. And there is a famous book with this title for those who are following macroeconomics, and famous book. No comment on the book, but I took these words from there. And many economic experts focus for financial crisis that never materialized. And those cautioning of upcoming crisis have no idea of the time of its occurrence. Many who had correctly predicted the crisis had warned that it is imminent when in fact it occurred many years later. And if you think of the financial crisis of 2000, 2001, I think the first flag has been raised by Greenspan, where he mentioned the word exuberance, irrational exuberance. This word has been given to him at the same day of the meeting by Schiller from Yale, who got all the credit for forecasting the financial crisis. But if you look on the prices of the stock market before 96, or at the time of this announcement, it was still significantly below the prices that occurred after the crisis. So it didn't fall. The warning were before, but nothing. It was not, the calling of the time was not correct. Second, the other extreme, sorry for all the Brazilians that I'm speaking also on soccer. So,
chairman is Argentinian, so it's not only for us.
Is what? Argentinian. Okay, we have a secretary, an administrative in our Center for Rationality in Jerusalem, and when I went to tell her, wish you do well in the later stages, she said to me, for us, we already won. Brazil is out, for us that's enough, we don't care anymore. So, okay, so if you observe a play of a soccer game, or you know the quantity of both competing teams, we can recognize a clear advantage of one team over the other. I wouldn't say what is the advantage in Brazil against Argentina, not to take any risk here. Therefore, a correct forecast is that the stronger team is more likely to score the next goal than the other team. However, it is impossible to be sure as to which team will be the first to score the next goal, and moreover, it is impossible to forecast the time of the scoring. I am always puzzled with various commentators that speak of the game and try to analyze why exactly what happened in the minute 42 of the game, the team A scored against team B. They try to find specific events for that particular scoring of the game. In my view, this type of analysis doesn't have any value. So, in both examples, the state of the economy or the score of the game can dramatically change in a split of a second. And players' action impact the likelihood of each state change. So, motivated with the soccer example and some issues that come with soccer, I have a graduate student, and I posed him a problem to develop a theory, and when he failed, I started to take it on myself. And I'll tell you what type of insight you could sometimes get about soccer later in the game. So, the question is, first of all, what is a game model that captures a lot of the issues that we are facing in either these financial interactions, economic interactions, that have an abrupt change of a state from a score of 1-0 to Germany to go to 2-0 and then to 3-0. So it's an abrupt change. It happened in a particular second, in a particular minute. And it is impacted by what the players are doing in the game. So this is what's called the stochastic game, is a perfect model to try to analyze such situation. So I'll start to tell what are, and that's an old model introduced by Shapley in '53. And after finishing its description, I would tell its shortcoming and what is the need for the new tool that will enable to analyze few of the situations. So the possible change of a state between different stages of the interaction, it takes account of such effect. And the likelihood of each change is impacted by the player's action. So it's not a change that is given from God or somebody out of the interaction is generating, but the actual players of the game affect where we are moving. If you think of Brazil against Germany, so, so the actual, I'll tell you at the very end why it's not so terrible that it was 7-1. So if, if you look, obviously the probability of scoring another goal and so on, these things were being affected by the players' actions in the game. So what is the game? So how could we think about a stochastic game? So it proceeds in stages. And that's a general point here of view. We as game theorists want to have a nice closed model. So most of our models of repeated games, etc., we have stages. Stage number 1, stage number 2, and we try to analyze what is happening in these stages. So it proceeds. So the state t, at time t, the game is in a state which we denote zt. This state is observed by all players. So that's the common information of all the players. that I know at this time. Thereafter, player choose an action profile AT. When I say a profile, it means all of them choose simultaneously their own action. The game moves to a new state, ZT plus 1, so that's the state in the next stage, and the current stage, ZT, and the action profile A at time t affect the conditional distribution of the next state. So just the present actions affect what is going to happen in the next state. In a play, when we want to describe what happened in a game, we simply start with the sequence, the initial state Z1, the initial action profile A1, Z2, and so on. So, to describe the game, why it's once, okay. So we have, first of all, we have to specify the set of players. So when it's a soccer game, it's two teams. You could think of Brazil and Germany, but could be Argentina against one, Holland, etc. So a set of players we have, it need not be two players, it could be a large number of players. We have a state space, which describes the evolution of what the things are stating. If you look on soccer, the state of the game at every moment if the game is the score, 1-0 to one team, or 3-2, or whatever it is. And then, for every player I, we have a set of possible actions that they could take. In the common literature, stochastic game 1 allows also for these actions to be state dependent, so to depend on the state Z, but for simplicity of notations, and there is, in many cases, no loss of generality, I assume it's the same set of actions. Then we have payoffs. We have stage payoffs. So the stage payoffs is some function that is a function of the current state, the current action profile, and that's the payoff to player I. It's convenient to think of G as the vector payoff, one for each player. And as you see, it depends on the state and the current action, so it's defined by some function from the state times A to Rn. And then we have a transition. So as I told you, that the action of the player in the given state affect the probability distribution of the next state. So this is standing for the next state, when they take now the action Z and A. So the ingredients defining the stochastic game, this B doesn't belong here. Okay, so this is just to describe the data that we need to define a stochastic game. But I claim that this stochastic game, for many purposes, is not sufficient. There is some lack in this model, because in a deterministic time, dt will stand for deterministic time stochastic game, it cannot capture the important common feature of the two motivating examples, that the probability of a state change in any short time interval is infinitesimal. So there we know that the probability is exactly either at time 1 or at time 2 or at time 3 and so on. We cannot have in this model the possibility that this time is continuous, and it could happen in any one of these. So this important feature can be analyzed by studying the asymptotic behavior of a sequence of stochastic game, where we think of the stage duration to go gradually to 0. So we look on the stage going to 0. The individual states represent short time intervals that converge to 0. And the transition probabilities to a new state also have to converge to 0, because I wanted to say that if every infinitesimal amount of time, the probability of changing, moving to another state is very small. So the probability of Brazil scoring at the minute at 23 and 30 seconds is close to 0. Yes, give me any small interval, it will be very close to 0. So to define such a sequence of games, you define a parameter delta that represents the duration of the stage. And for every delta, you consider a game where the payoff and the probability transitions are a function of delta. So the play is the sequence Z0. I switch from starting at 1 to starting at 0 because it's good for when we move to continuous time. It's here a typo, but it's in this anticipation. And we shouldn't understand the state Zn of this game as the state of the game, of the soccer game, of the economy, of whatever kind of continuous interaction we think, at the time that is n times delta. So delta is a short time interval. At half time, tell me, please, okay? So the question, the first question that arises is, under what condition? Yes, we have here a family of stochastic game with short stage duration. We have here some parameters which are the transitions and the payoff which depend on delta. And the question is, when can I say that they have some form of convergence? Okay. So the characterization of this type family of games that do converge is given in a paper of mine, Stochastic Game with Short Stage Duration, in 2013. This was a volume in honor of 60 years of the Stochastic Game paper by Shapley. And where in this paper, in addition, it's quite a lengthy paper. And in addition, we have there an extensive study of the asymptotic behavior of the equilibrium in this type of sequence. So we don't only say that this models this and it converges to something, but also tell what happens to the equilibrium in this sequence of games. But if you think a little more, if you think of rational numbers, and you want to think of what do the rational numbers converge to, you have sometimes a sequence of rational numbers that converge to an irrational number. So a natural question in such a setup is to try to think, if we have this type of game, what is the object that idealizes all the features of these games in the limit? What is the limit of such games? And the limit of these games are the continuous time stochastic game. When I started, I didn't know that there is any work on this topic. And then I discovered that in '64, an author by the name Zarichson wrote a paper called Markov Games. And basically the model, it was a two-person zero-sum. The model was essentially the model of continuous time stochastic games, two-player zero-sum. But it didn't address some of the conceptual difficulties that appear when you start to handle continuous time games. When you have continuous time games, there is one, I wouldn't touch it too much here, but there is one critical problem. In game theory, we usually define a strategy, what the player does at every point of time as a function of everything that happened in the past. It is not the right definition in continuous time. Because there will be many such strategies that would have no meaning at all. It means you wouldn't be able to integrate from the strategies anything about telling what will happen in the game. So one is to switch to a larger class of strategy. The earlier studies of continuous time stochastic game have basically taken a shortcut and haven't considered all strategy in these games, but considered only all those strategies such that the action at every time depends only on the time and the state. So you cannot basically have any reciprocity argument, etc. Okay? And moreover, so if you have such a strategy, then you could more or less work with it. And what we discovered is that, how much time I have? Okay, very good. What we discovered is that there are new results, and each one of these new results was also supported by the finite approximation. So you get a result on the limiting model. So you say, okay, the limiting model, you could think this is the model, but you always want to try to see if you could back it up with results of the finite state duration when the stage goes to 0. So all these new results on the continuous time stochastic games are backed by such asymptotic results. So what do we have in a continuous time? What's the feature? We have frequent action choices. I could change it in any measurable way that I want when I playing the game. So I can change my action as frequent as I wish. State changes over time, as in the stochastic game. Stage payoffs depend on the current state and actions. States transition depend on current state and actions. So the ingredients will be the same as before, almost the same as before, just the transitions will be a slightly different object, which I'll define shortly. So N is the set of players, we assume finite, A the action profile is finite, Z the state space, finite, and one of the reasons of working with finite, it's not that you cannot extend the model to an infinite state space or infinite action spaces, but the positive results, two things. The positive results are mainly the difficult ones for this setup. They don't hold if we weaken any of these assumptions, but this will be the result at the very end of the talk. And B, there is a conceptual thing. If I want to study these games with discontinuous state changes, if I have a finite state space, it must be, or a discrete state space, all changes must be discontinuous. So in the examples that we mentioned before, they were all discontinuous. So we have a stage payoff. So when we look on the game evolving over time, so for every time t, we could define what is the action profile in the action profile set A, what is the state, and this changes with z, and what is the payoff function, which is a function like before of the current state zt and at. Obviously, you could interpret it as a density of the payoff. And then comes the new ingredient, which we have to think a little. And sorry for mentioning here again the game of Brazil against Germany. So if you look at some minute of time, and the score is 2-0 to Germany. And then they continue to play, and you observe, you are the coach, you think what's going to happen. So basically, another example. Okay. It's too touchy. Let's go to the games in England, okay, or the Champions League. I think I'll give later an example. Some moral from that story on the UK League games. So let's focus on that. If you look on a given game, and you look on Chelsea playing against West Ham, so you say there is some advantage to Chelsea, and you think in this situation, the way that they will play, it might be that Chelsea will score on average, in expectation, 2 goals in a game. You cannot know when the goals are being scored. It's not half time at the end, or 1/3 and 2/3. So the way to model it is to define the intensity of scoring a goal. So if you start at the beginning, and you say 2, so it means that in every single minute, the probability of scoring a goal is, so the expectation will be 2 in the entire game. In every minute, 2/90, assuming the game lasts 90 minutes. So 2/90, 1/45, that's the probability of Chelsea scoring a goal. In every minute of time. How many goals Chelsea will score in the game? We don't know. It's a stochastic variable. Who knows the property of this stochastic variable? It will be what's called the Poisson distribution with expectation 2 in the entire game. So there is some distribution which I could know what it is. And West Ham is scoring on average 1 goal per game. So it means that in every single moment of time, they would score, the probability of them scoring is 1/90. And then the total number of scores that they will score will be a Poisson distribution with expectation 1. That's an exercise in probability for those who knows probability. Still, it might be possible that in the course of the game you take two independent Poisson distribution, one with average 2, the other one with average 1. It is still possible that West Ham will win or that there will be a draw. It's only an expectation. It's not something for sure. So what should do when the players are playing? This ratio of 2 to 1 is a function of how the teams are playing. West Ham could switch, if they want, to another system of playing to bring into the game another attacker and to take out another defender. And then maybe it will be a play such that Chelsea will score on the average 5 goals in a game. So every every 18 minutes they will score on average a goal. So, but this is the game, but West Ham will score 2 goals. Okay? So a priori, probably if you will make the computation of the Poisson distribution, you will discover that to start with such a system, it's not worthwhile. It's not good to start with such a system because the likelihood of you losing is more than in the previous one. But if 60 minutes have passed and Chelsea is leading 2-0, and now there is it's not an entire game, and if you could switch the tactics of the game to impose such a distribution, I don't know exactly, didn't make this explicit computation, then it might be worthwhile for you to switch, for West Ham, to switch the style of the game. Could I come back to Brazil, Germany? So, how come that the score was 7-1? Okay, I could tell you few reasons, but I think I want the reason that is related to what I'm talking here. After Germany scored 2 goals, and maybe in the game a priori it might have been a ratio of 2 to 1. Now if they continue with this ratio, they will get very likely a loss. So it's worth for them to change the play of the game in such a way that they are risking a lot of goals at the probability of they are scoring more goals. So the defense is very weak. And therefore, after 3-0, you change it even more. So you have an acceleration of scores in cup games when one team is losing to the other. So after a given amount of time. So I said I'll speak something about the UK League. So I was thinking, I asked my student that was working on that, look on the quality of coaches in the UK. Let's try to see who are the coaches that are navigating better the rate of scoring the style of the game as a function of the results evolved. And who was first? You know the coaches in Ferguson. So, no, I think Ferguson was the best coach in this aspect. You know, different teams could have prepared them differently, but if you would try to compute the Poisson distribution of how much he should have scored in every game and how much he should receive, you could have computed probabilistically how many points he should have in the league. He always had much more in every sample. So it means he knew how to navigate after they are leading to play a more cautious game and to do it in the right time. It's not just to say qualitatively, it's a question of complex optimization. And my friend Grant, who was coaching Chelsea, was very poor in that. Okay, he was basically scoring the same amount of goals as if he plays same system throughout the game. Okay, so how do we define these rates of transitions? So, as I said, if I think of duration delta, and if I try to think what will be the transition rates if within time delta, from when we are at state Z and take the action A to state Z prime, if this will be this quantity, the only thing that makes it compatible with what we talked and what we gave the example of the game is that this term is approximately delta times some function like that. So this defines the transition rates. And obviously, if you make a little computation, if you want to see what is the probability of of staying in the same game, it will be 1 minus that, where I take this to be negative the sum of those things, so that the sum will be equal to 1. So you get a condition of these transition rates, and they define to us the game. So the condition of these transition rates, moving to a new state, it's non-negative, and staying at the same state is 0. And this, if we look at the previous definitions, it defines a kosher game. So here are the ingredients of the game. And now, how much time I have? 10 minutes, okay. So let's look on time separable payoffs in this continuous time stochastic game. So if we are given a list of measures here, I should wrote probability measures. Yes, a probability measures on 0 infinity, so it's a 1 for each player. The continuous time stochastic game with time separable valuation W is the game where the payoff valuation of player I of a play, so a play tells us the sequence of states and action, is this integral of this payoff at time t, dwi of t. Does it fit our soccer game? So maybe one more slide. Given a strategy, we could compute the expectation, the payoff to this strategy. And if you think of the soccer game, it corresponds to the game. The wi is the Dirac measure at the end of the game. So we don't care about the score in the course of the game. We just care about the score at the very end. So it's a function just of the state at the very end, and the state is the score. And now at theorem, for every time separate evaluation W like that, there is an epsilon equilibrium. For those who are unfamiliar with epsilon equilibrium, I'll just repeat it. For every epsilon, there exists a strategy profile, such that for every player and every single deviation, this strategy, if you switch to tau I, you cannot improve this payoff by more than epsilon. Economists usually try to focus on exact equilibrium. I think people in the real world usually are happy with epsilon equilibrium. Sometimes they are happy with epsilon equilibrium because they don't know exactly the game, so they would prefer to have an epsilon equilibrium in a large family of games nearby. Okay, so one could have here given another result, which I haven't written, that if we have a sequence of such time separable valuations that converge to W, there is a strategy that will be an epsilon equilibrium in all these games sufficiently far in the sequence. Okay, so again, just a reminder, a strategy defines in the continuous time game a probability distribution over the play, and therefore it defines a distribution on the streams of payoffs. And now I'm going to speak about the highlight or the main result of this type of work. And on something related to it, I'm promising this prize. So let's look on the situation, the economic situation. So we have the payoff. So usually we are thinking of discounting. But what does it mean, discounting? So everyone, usually to write a model and work with discounting, it takes one discounting factor and assumes that this is stationary throughout. There is no reason to think about it. You could have different discounting. You could have discounting that differ between the different players. If you look on global warming issues, then some players have a weight on the payoffs that they are receiving in their life horizon, and the central government should have a much more patient valuation of what's happening in the economy, so they'll have something spread much more. And moreover, the central government wouldn't know exactly how to evaluate the payoffs in different stages. They want somehow that it will be epsilon optimal maybe for all of them. So they have an idealistic solution there. So W is a general discounting if for every player I, the weight that the measure gives to payoffs in the interval A plus C, B plus C, when I push C, increase C, it's not increasing. So a stream of payoffs in the next interval of time, in a later interval of the same length, is worth to me less than before. So this will be a general discounting. And the main theorem is that if WK is a sequence of generalized discounting such that for every A less than B, so remember general discounting, we mean probability measures. Okay, it's important, but we'll focus here for. So if W is a sequence of general discounting such that for every A less than B, this converges as K goes to infinity. So the weight, it approaches a given weight that I'm putting to the payoffs in time A between A to B. Then for every epsilon, there exists a strategy profile V, a payoff vector V, and a positive integer K epsilon. I think of it as far away in the sequence. I want to get something asymptotic in this, such that for every player I, for every possible deviation by player I into a strategy tau I, and for every K larger than K epsilon, the payoff, so a typo here. Here it should be this a WK. Okay, so this WK should have, which for every K, here in the sequence there is nothing K. So this is W of K, the valuation in the sequence of K. So this is at least this VI minus epsilon, and by the deviation here, you don't get more than VI. You cannot improve your payoff by deviation by more than this VI plus epsilon. Any question on that? Oh. So before I go to the last slide, I say that I'll promise some prize for some problem. So, you know, this is a result about the continuous time game. A priori, it might look to us that, how much? A priori, it might look to us that the continuous time game is a more complicated object. So if we prove these results in the continuous time, what will be the situation in the discrete time? So in the discrete time, this WK would be a measure on the integers. Discounting measure, it means it gives decreasing, non-increasing weights to different integers. Probability distributions for each one of the players, a different probability distribution. And I want to know if for every such sequence, there exists such a strategy sigma profile and tau such that far away in the sequence, it means here it's WK and here WK, we will get this inequality. So if you prove that, business class plus restaurant anywhere in the world. If you prove that it's not true, then only the dinner on me, on a restaurant on your choice. And maybe I was a little puzzled when I managed to prove this result. And I was trying to understand why, what makes, in many aspects, the continuous time is more complicated than the discrete time. What makes it easier? Because sometimes if we think of equilibria as a kind of an agreement between the players, what we are doing, how we reciprocate, etc., in the course of the game. So what makes life easier in a continuous time that enables this theorem? And the reason is that reciprocity is much better facilitated by continuous time, because in continuous time I could tell you, play this action. Maybe we'll jump to some state that is very good for me, but very bad for you. But you are risking very little. Okay, so I'll gain 5 more than what I expect. You would lose 1, but the chances of us jumping there is very small. And if you do that, I'll reciprocate you in the next stage. If we do in discrete time, it might be too late. So there is a positive probability of transition, and therefore it does enable this type of reciprocity. So, thank you for listening. Thank you, Marilda, that she's not here. And happy birthday to Marilda, but she's not here. Thank you.
Thank you. If there are questions?
Just try that you can use that?
Because we are looking on a stochastic game. So reciprocating, there could be some state that is absorbing. We reach there, we stay there. Okay? So if you take an action that we are getting there, in the discrete time we'll get maybe for sure, maybe it's deterministic. In continuous, I'll get there at 1/10 of a second, I'll get there only with probably 1/10 times that, and then I could still reciprocate. We are there.
And this property of discounting going down plays a role, no? In the sense to avoid this
Yes,
point.
yes. It's the fact, it is not true if I take the sequence to converge, but it wouldn't be a decreasing sequence. So it plays a very important role in the proof. Let me say one more thing for those who are going after the talk to work on the open problem. It will be enough.
I'm very interested in the problem.
Yes, it will be enough to solve it in the case that the way WK is 1 over K on stage 1, 1 over K on stage 2, 1 over K on stage K. So if we look, if we manage to prove the previous conclusion for this particular sequence, then I know to prove this theorem. So I have a kind of, to this part of result I call discounting robust equilibrium. To the previous one that I just mentioned, I call a uniform equilibrium. And one of the other terms in the paper is that you have uniform equilibrium if and only if you have discounting robust. Okay. Thank you.
Okay. Other questions? Thank you very much.
Is there a soccer game afterwards?
So we are going to come back 2:30.
Yes, it's for you. So was coughing a lot.
Yes, I have the phone.
Tá, isso vou dar. So, when I start again, good afternoon. Sorry for the long delay, but you know, it was hard to organize those things at the same time. So, pass to Professor Rubens or Dean.
Thank you, Humberto. I will ask our minister and also professor of our school, Marcelo Neri, to say some words in honor of those who are here with us today. Please, Marcelo.
Thank you very much. It's a great pleasure to come to my home and that is hosting such an important event. What's very interesting about Brazil is that an event like this can generate really lots of impacts later on. When you come back here, those of you who came from far, you may see a difference in the way we think, the way our policies are designed. So it's really the interesting part of Brazil. That's a country in motion. But sometimes we get stuck, in, you know, for a long time. So that's why. So I would like to pay my tributes to Marilda. Marilda, thank you very much. It's for us a great honor to honor you here. I had the opportunity, although it's not my field of research, to meet Marilda in my first international seminar was in Punta del Este in '91 in Lames. Some of you were there. And Marilda is a very important leadership. That's what we need in Brazil, leadership, especially in the academic area. And this seminar and the USP seminar is a very concrete proof of her contribution, of how she's recognized in Brazil and elsewhere. As Professor Carlos Ivan said, you know, you have to have endurance, and that's perhaps the main, most important characteristic, is not to work in a very high level, but work in this level for a long time. And that's what I think in an area where you don't have so much interaction in the country, because maybe if you are working in a policy area, you have lots of people which you can talk, but to work in in the building of the theory in this country for such a long time, I think it's a really a very, very important and unique contribution. We have here Marilda prestige and importance brought here 4 Nobel Prizes to our country: Professor Robert Aumann, Eric Masking, Alvin Roth, which is a co-author of Marilda herself, Professor John Nash. And unfortunately, Brazil, we never had a Nobel Prize in no fields yet, which says something how much we have to improve in our education, in our science. And so this is very important. I had the opportunity, I was at Princeton in '94 when Professor Nash won his Nobel Prize. For me, it was a very important part of my life, a moment. And I think this, you guys give us a very important signal for the next generations, and we are really very grateful about all your influence on our work. The fields that Marilda works and that are treated in these events, like theory of contracts, theory of information, matching, auctions, they are perhaps the most, and rules of voting, they are very important for building our economies, our societies. I would like also to thank Danilo Coelho and Humberto Moreira for organizing, and other people to organize this event. This is really, and I'm very impressed by the number of people that are here, in spite of the delay we had. But I think delay in this case is a good thing, because is a collateral effect of the emotions we are all feeling, so we cannot go very fast during this process. We have to enjoy it. I think this initiative led by Danilo and Humberto is very important. When you connect a school like EPGE, which has this characteristic of building theory on Brazilian grounds, and connecting with EPGE, which its main mission is to propose solutions for the main national problems, we get really a different effect, this combination. We had a few weeks ago also another joint initiative that went to São Paulo, to Rio, and a final seminar in Brasilia on public purchasing, and really creates an impact. It's amazing how much you change how people start to see, and within government, the way things should be done. And as I say, this is not my area of research, but I think I think Brazil, we have, as other countries, many problems, but those problems, which are typical Brazilian problems, are very much coordination problems. Like we had inflation for such a long time. No other country in the world had higher inflation than Brazil had. And my first step to game theory, to where I learned, was an application to coordination problems, relation to inflation, how to explain inertial inflation. Professor Mário Henrique Simonsen brought this idea to Brazil. But I think, we had very high inflation. Fortunately, it's lower now. Had very high inequality. We had lots of coordination problems, and I think the game theory and all the techniques and the ideas discussed are very important anywhere, but especially here. I think we had a few years ago, I think Rubens will agree with me, all economists in Brazil were basically macroeconomists. Then we went to a phase where we start to look more at social economics, etc. And I think what we really need is a similar effort on the microeconomics. That's a revolution that we didn't go that deep, and I think this seminar is rather important to push us in this direction. So I'd like to thank everyone that organized this seminar, and in particular give my honor to Marilda for this very, very special day. Thank you very much.
Thank you very much, Marcelo, for bringing your reflections to us. I have done my acknowledgments about the sponsors, about the organization, and about the day that we are facing today, earlier in this morning. So I'd like to say something about what we're actually doing here, in my opinion. I think that our ancestors, thousands of years ago, in occasions like this, in which they wanted somehow to separate the ordinary facts of life from special moments, or put it some way differently, to separate the sacred from the profane, but not talking religiously. They used to dance around a fire, so they would come up with the idea of looking for some firewood, could not be wet. I do not know how they managed to get the fire working. And they would hunt some animals, put those animals there so that they could have a very good time. And somehow they would gather around a message. The message could be anyone. For instance, our tribe is superior to all the tribes in this region, or we are the strongest, or some things like that. Well, nowadays, we do exactly the same thing by different ways. So we do not stay around a fire. We usually congregate over a table. We have a fork, we have a spoon, we have a dish, we have some different manners. But ultimately, what we're doing is the same thing. And it's going to be the same thing as long as the human people, the human race, if you want so, is around this planet. Because that's the ultimate and one of the most original things that you can associate with groupings of people, is to try to separate the ordinary facts of life from special moments of life, like this one. And in moments like this, besides conveying a message, there is usually some tension in the air. So if you take, for instance, the ritual, this is a ritual. If you take the ritual of a wedding, there is all that expectation about when it's going to be, when the doors of the church are going to open, how she's going to look like, and how she's going to go through till the altar. And within the tension, which is an increasing and subtle tension of these ceremonies, and I have the conjecture that these tensions are unconsciously produced in our brains because they fix the memories. Attention, fix memories. And so we somehow devise these instruments of fixing memories, and there's this tension within the tension. For instance, when the bride happens to stumble over her gown, and or when the groom forgets the rings at home, or thinks to have forgotten them at home and starts to look in his pockets. So there's this tension inside the tension. So it's all part of the ceremony. And what's the message that I think we should convey to this ceremony? I think the message I would like to think about is, what is a life worth living? I don't know. I don't know, have no idea what is a life worth meaning. But we usually talk about things, the definition of which we do not know. For instance, what is justice? Well, some people would say justice is very simple. Simply pay your debts and speak the truth. Some other people, like Polemarchus in Plato's Republic, would say truth, it's very simple. Justice is simply doing good to your friends and doing harm to your enemies. That's another justice of another notion of justice. Or you could have somebody saying justice is having those in the lower strata of society having the louder voice, like John Rawls. We do not know what justice is, but look at that. It's very interesting, because if I say to you that citizen A was stolen by citizen B, and I had citizen B give back to citizen A what he had stolen, you'll probably say to me that what I have done is just, is fair. But how can it be that we exercise notions, the definition of which we do not know? It's a tricky thing. So I'd like to come back then to the idea of a life worth living. I do not know the definition, but I would dare to establish what we do when we do not know the definitions. We try to establish a axiomatic, and we give some examples. I think, very modestly, that a life worth living, for sure, must have a component of creation. It's nice to create, to come up, to devise things nobody had thought about before. This is nice. A life worth living should have components of sharing, because sharing is all about life. It's all about being together. So this is also, I think, a component of a life worth living. Dissemination of knowledge. And I was here 2 days ago when I heard our president saying one thing that I have included in my previous axiomatic. He said, we should believe. He said, we should believe. And I went home late at night, walking from here to my house, which is like 10 minutes from here. And the whole time I was thinking about that. I think he's right. A life worth living has to have a component of believing, of seeing a point in a certain horizon, and by means of persuasion, never of authority, trying to convince those who are with us that their point might lead to a higher welfare, if not of all, at least of the group as a whole. And I said to you that we are able sometimes to give examples to try to show what we mean. I gave you the example about justice, which was somebody stealing something and having this thing given back to the one who was stolen, and that is probably just. So what is the example of a life worth living? Well, I dare to say very modestly that Professora Marilda Sotomayor is an example. I dare to say very modestly that Professor John Nash is an example. And if you allow me, I dare to say that all of us, by congregating here to honor this idea at the same time of sharing, disseminating, creating, bringing knowledge, making people discuss, bringing things to our community, bringing things to our city, to our state, to our country. These are great things. Thank you very much, you all.
So in this moment I would like to call Professor Peixoto, Maurício Peixoto. Dear Professor Maurício Peixoto, can you come here, and Professor Lindolfo as well, to honor Marilda Sotomayor. Please come here.
Since Humberto left the microphone, I'll say we have a plaque to hand to Professor Marilda Sotomayor. And so we have asked the president of the Brazilian Academy of Science, Professor Maurício Peixoto, and our provost, Professor Lindolfo, who both have done so much for our foundation, for science in this country, as former directors of IMPA, Institute of Mathematics as well, to please deliver the plaque to Professor Marilda Sotomayor.
Thank you. I don't have words. I am not expecting that. A FGV, por ocasião do workshop on Game Theory, homenageia a professora Marilda Sotomayor pelo seu aniversário e reverencia sua contribuição à ciência econômica no desenvolvimento da teoria de matching.
Congratulations, Marilda. So let's work now. We'll call Danilo to organize the session of the afternoon, and to start the work again. Thank you.
It's a privilege to introduce Professor Inés Macho-Stadler. She works on information theory and game theory and contract theory. She has several papers. She also is author of one of the most important books in information theory that most undergraduate courses use this book. And it's a pleasure for me.
Thank you very much. Sorry, I cannot be fixing it. Okay, it's a pleasure. Well, it's difficult to talk now after this nice and more sensitive moment. Okay, so let me present you a paper. It's a joint paper with David Perez Castrillo, who is also here in the room, and with a very dear friend, Nicolás Porteiro. And what we are trying here is to include a model of incentives. That's why the contracts long and short term is a model of incentives within a matching model. Okay, the matching model, as you all know, or you may all know, is a model that tries to find what is the equilibrium in a market. The first models where there was no money. The marriage market is a typical example. Then there is money bringing to the picture, and a natural extension is to have contracts. Okay, That's interesting from the point of view of matching. I am coming from the theory of contracts, so my interest is a little bit different. In the models of moral hazard, the model of incentives, in general, the people that are participating, the principal and the agent, are predetermined exogenously. So you have some people that you don't know why they are together, they are trying to sign a contract. What we think is that by bringing these people to a market, by bringing the principal and the agent to a market where different principals and different agents meet in such a way that the partnerships, the people that at the end of the day are signing the contracts, is not exogenous, but is endogenous and determined by the market, may be very interesting from the point of view of knowing things about the contracts. And in fact, as I will try to tell you in this example, what is the typical prediction in a predetermined agreement may be slightly or very different when we are including this agreement in a market in which the people that will sign the agreement are also determined. Okay? So, sorry. So that's what I will do. I will present to you contracts, which main characteristic is the length, the duration. That's where the short-term and long-term contracts come from. I will have incentives, what in the terminology of the information literature is moral hazard problem, and I will bring that to an assignment game to a market. There is literature on both problems, and I will escape it. If someone is interested, I will be very happy to talk to you at any time or give you information. Let me go directly to the model. The model is a little bit long, but it's not very difficult, and it's a very simplified way of considering a market of workers. Okay, so in my model, there will be firms, infinitely live firms, so firms that will be there forever, and they have a project or a type of production process. And there is also workers. The workers are only live for 2 years. In the first year of their life, they are juniors. In the senior year of their life, they are seniors. And there is an overlapping generation situation. So every year there is a generation of juniors that arrive, and the next period they are seniors, and they will live at the same time as the new juniors arrive to the market. Every firm that has this project has a part of the project that gives several profits. That's what I call F, and they will not show up a lot in the presentation by now, maybe at the end. And in addition to this fixed part of the profit that will get whether there is success or failure in the business, there is a part that is called R, and is a part that comes, the firm only receives it if the firm is successful, okay? And there is a probability of success, so this is R. There is a probability of success, and this probability of success depends on the ability of the person that is running the project. And this person has to be a senior in my model, okay? So in order to produce, the firm needs a junior. The junior helps in the production, and while he is working in the firm, he is learning how to be a senior, how to run a project, and in addition, the society, the market is learning the ability of this junior, okay? Think, in my model in this sense is very simple, our model is very simple in the sense that we assume, we can discuss other things, but we assume that the ability of the junior is observed by the whole market, okay? So it's, as in the case of academics, your papers, your performance in conferences, your research is publicly knowledge. If you're a singer, whether you sing it well or not, or you're a dancer, that's public knowledge. If you're a soccer player, whether you play for a club or for another one, how good you are is observed by the whole market, and you only show that when you have begun to work, okay? A priori, maybe more difficult to know whether you are a successful singer or a good player, soccer player, or a good academic when you are young. So the element that is more important in our model is that the juniors learn, they show their characteristic, but after a period of working in the market. And as seniors, they may be good or bad. Okay, and a good senior or a bad senior is a senior that has a higher probability or a lower probability of having success when running the firm. Okay. In addition to that, in addition to the characteristic, we assume, that's why we have incentives, that the seniors may work more or less, okay? And that's the effort, and that's why I have this moral hazard problem. We assume that in the population there is a proportion, ex ante, there is a proportion Q of high ability players and a proportion 1 minus Q of low ability players. Okay, there is a discount rate. As for the juniors, they learn, but we assume there is no element of incentives here, so they will receive a fixed salary. Okay, the seniors need motivation, and in contract theory, motivation comes by writing a contract that makes the payment depend on the result. Okay, so for the seniors, what we will have is a contract that says, if you are not successful, you will receive a base salary. If you are successful, if you get this R, then you will receive a bonus. Okay? So the contracts for the life of a researcher will be, as junior, you will have a fixed salary. As a senior, you will have a base salary plus a bonus. And this base salary and bonus may depend on your ability. If you have shown in the market, or you have shown by performing or by training you in the market in the first period that you are good, then you will have the base salary and the bonus of a good player or a good senior. If you have shown that you are not that good, then you will have a fixed salary and a bonus of a less good player. Okay, that's what I mean by this base salary and bonus. Okay, what's the difference? About a short-term contract and a long-term contract in this model? A short-term contract is a contract such that if you are the worker and I am the firm, I go to you when you are a junior and I say I promise you this first period that much. And tomorrow we will see. Okay? Then you become a senior and then tomorrow I can hire you again, another firm can hire you, we can sign the contract that we prefer at this moment in time. What's a long-term contract? A long-term contract is a contract in which I go to you and I tell you I will contract you today and tomorrow. In the long-term contract I am offering to you, and if you accept, you have to honor it for all the duration, is a contract in which I will pay you that much today, and tomorrow, if you are good, I will pay you like that. If you are bad, I will pay you in this other way. The commitment on the part of the firm is more or less easy to accept. The commitment not leaving the firm for a worker may be a little bit less usual. Okay? While we are doing that, because that's the scenario that is more often discussed in incentives, and I want to keep the same structure as the literature. But in addition to that, because it's true that in several of these activities I was telling you before, it is not true that the worker can never leave the firm, but there are mechanisms that try to mimic this condition. If you are a CEO in a firm and you want to leave the firm, and you have signed very often a non-competition clause, and you cannot work for any other firm on the same industry for 2 or 3 years. Okay? If you are a worker that is studying while you are working in a firm and the firm is paying your education, if you leave the firm, and you have to pay for this education. If you are a comic writer and you leave the editorial where you have been publishing your comic books, then the characters you have, they are no longer yours. They are from the editorial. So you lose a lot if you leave the firm, and that can be seen as a commitment. Okay? So what I will try to explain to you is in this infinite game in which the firms last forever. They may be different. Everyone is always the same, but they may be different. There is this generation of workers that arrive, and I want to know whether the firms will sign long-term contracts or short-term contracts, and I will concentrate on what in the literature is called stationary equilibria, because my model is stationary. That means that every period is similar as the previous one. There is no learning by the firm or changes in the firm. Okay, it's stationary in this sense. But I need to have periods in order to have long-term contract and short-term contracts. Okay, so my population of firms, imagine that the firms are in the interval R lower bar, R upper bar. The population of firm in equilibria will be distributed at most in 3 categories. The group of firms that sign long-term contracts, these are different firms. As Abraham was saying this morning, imagine that they are soccer teams, okay? So there are some soccer teams that are better and some soccer teams that are worse, okay? And everything is random in my model. But there are different types of firms. And in these different types of interval of firms, some of them will be signing long-term contracts, some of them will be signing short-term contracts. And if there are firms that sign short-term contracts and go after in the market just to pick the best seniors, if they go to the market because they only want to have the best, the one that have realized to be the best one in the market, say whatever soccer player you want, there must be others that will hire, they will never hire the good ones, that will hire the bad ones, okay? So that's why I have this distribution in between the firms that will sign long-term contracts. If you sign a long-term contract and your senior is good, you keep him. But if you sign a long-term contract and your senior is bad, you also keep him, okay? Because your commitment is to stay together for all the duration of the relationship. While here, we will have firms that sign short-term contracts. In the second period, when the seniors, the workers will go to the market, and they will go to the market, so some of these firms will hire the goods, and some of these firms will hire the bad seniors, okay? Yeah, that's what I will try to find the equilibria. That's endogenous. I will try, but for sure it has to be like that. Some of these sets can be empty, but at most I can have that. The ones that sign long-term contracts and the ones that hire with short-term contracts and are specialized. I will tell you why they are specialized in a moment. By now it's not clear, but so that's what I will try to determine. Okay, so the first proposition that comes, in fact, from what we know from the principal agent literature for the predetermined couple. So there is a partnership, a principal and an agent that have a long-term relationship. What we know from this literature is that it's optimal to sign long-term contracts. Okay, and that's what this proposition. Is that with this proposition says, okay, if everyone in the society, if all the firms are signing long-term contracts, one firm has never an incentive to deviate and to sign short-term contracts. Why? Because in the literature of incentives, the long-term contract is always superior to the sequence of short-term contracts, in particular because one particular long-term contract is to sign this sequence of short-term contracts, okay? So you can only do as good, as well by signing a long-term contract that a series of short-term contracts, and in fact they are superior because when you have a long-term relationship, you can tell to your agent, see, when you're a junior, I will tell you a little bit less. I will pay you a little bit less because tomorrow, when you're a senior, I promise you I will pay you more. Why, as a firm, I am interested on paying the agent more when he's a senior? Because that's the period in which I have to provide to him incentives. Okay, and the more promises I give him on tomorrow you will be promoted, you will have a very nice car, or you will earn that much, gives more incentives tomorrow. That is when I need to provide incentives. This I can do with long-term contracts. I cannot do with short-term contracts. Why? Because whether you are economist or not, I think you will think in the same way. If I tell you, see, today I will pay you very little because I don't sign anything today, okay? But tomorrow I promise you I will pay you more. I hope you will not believe me, because tomorrow when the day comes that I have to pay you more, I haven't signed anything, then I will say, you know, times are very hard, I don't have that much money, there is nothing that commits me, sorry to tell, but either you accept this other salary or nothing will happen, okay? So I can do things with a long-term contract that I cannot do with a short-term contract. This is the equilibrium that is interesting, say, in a predetermined relationship. Let's consider now what happens if the relationship is not predetermined and we have this market in which the workers and the firms sign contracts, and in the spirit of the matching literature, the equilibrium is an unstable equilibrium, meaning pair cannot improve the contract, meaning the contract has to be optimal, and that there is no agent that is, or no worker that is obliged to sign a contract that he does not want to sign, and no firm, but at that I will not insist. I will just discuss at the end because I have this F component, but no firm will do negative profits, okay? They would have to do positive profits, if not, they will not be active in the market. By now, I will not insist on that. So the first thing I have to do is to find what is the optimal contract for a worker if the firm is signing a long-term contract, and what is the optimal contract for a worker when the worker and the firm sign short-term contracts, okay? And I will do that just because I will try to explain you why in here, okay? The first two lines, this line is this one, okay? Just the top part of this box is a long-term contract, for example, okay? It's a long-term contract in which the firm hires, take a period, hires a junior at period T-1, and then he will pay this to the senior at period T. At period T, the firm is also hiring another junior that will receive, so a person will receive this payment, this today, this tomorrow. We hire another junior that will receive this today and this tomorrow. Is more or less clear? Yeah? If this firm wants to change the contract, if this firm thinks on an improvement about this contract and it says, well, today at period T, instead of signing the contract I was considering, let me change the contract, I have to honor my contract with the junior I have hired the year before. So this part of the contract I cannot change because I am committed with that. I can hire the junior with a new type of contract, and then this junior as a senior will have whatever is my best contract now, and things like that, okay? So if you see these two sequences, in fact, I mean, this part is the same, before making the change is the same, and afterwards, the series are all the time the same, so what is important is just to consider what one agent gets. Okay, that's what this means stationary. So I will just consider what is the best contract for, even if the firm is in definitive life, since the firm will be all the time playing the same strategy, it's enough to see what happens with one generation of workers. Okay, that's what I do. So you don't have to make a lot of attention to that, but this is the typical problem you have to solve when you have a long-term contract. You maximize as a firm your expected profit, the fixed part that comes over always, the wage to the juniors, the probability that your guy is good is Q, the probability that the agent is bad as a senior is 1 minus Q, and these are the probabilities of success, how much the firm gets in case of success, minus the bonus that is paid to the worker, minus the fixed payment. Okay, so that's expected, it's just expected profit, it's letters, but it's just expected profit, subject to the participation constraint of the agent. The agent decides to sign the contract when he is a junior, so he has to be it has to be profitable for him for the two periods, when he's a junior and when he's a senior. That's his salary as a junior. This is the discounted amount that he has, the expected utility. With certain probability, he has his high ability and he gets this utility. With the other probability, he's bad and he gets this utility. And this is the overall life utility. These two are the incentive compatibility constraints, just came from the very simple problem we have. And this is the limited liability constraint that are very useful for us because it's the simplest way of having a moral hazard problem. Why I need a very simple moral hazard problem? I need a very simple moral hazard problem because for doing a matching model, we need to have the preferences, how much the utilities, how much the players get. And if you don't have explicit solutions, you cannot compare them. Okay, so that's the reason why this is simple. We obtain them for different intervals. We obtain the incentives, and what is more important, what I will use in what follows, is what is the profit of a firm of type R when the firm signs a long-term contract with the junior he hires, okay? Okay, that will be for the long-term contracts. Let's take short-term contract. What is a short-term contract? For shorter contracts, we have a sequence, okay? So we hire the guy when junior, and we have the guy when senior. So these are two periods. The sequence of short-term contract has to be optimal, subgame perfect. So we have to find how much we will pay for every type of senior in the second year of his professional life, and how much in expected terms I have to give to the junior, and the junior gets how much we pay him as a junior, plus the expected utility of how much, and that's the difference, how much the market will give to the seniors that are good, and this match came from the competition with other firms. On the long-term contract, there is no competition because we have the junior, we take him, and we have him forever. So there is no competition in this market, okay? Once the guy has signed a contract with you, he cannot leave. But under a short-term contract, he will work for you in the first period. In the second period, he will be again in the market, and then other firms may approach this worker and make offers to this worker, okay? So the junior, when accepting a short-term contract, takes into account how much he will get if by chance he turns to be good, how much the competition of the market will give to this guy, and how much the market will give him if he turns out not to be that good, okay? So we find that, again, we solve the problem, we have the profit of the firms, and now the profits of the firm have an subindex I, and have this subindex because under a short-term contract, you may end up hiring good agents, or you may end up hiring bad agents, okay? So we will have the expected profit of a firm that signs short-term contracts and specialize on competing in the market for hiring the best workers, and other firms, and I will try to explain you why these firms do that, but other firms that train and give this service to the market to identify the good workers, but at the end of the day, always hire the bad seniors, okay? So we find that, we find the profits, and then we compare them. I will try to show you the idea of the solution in a moment. We compare them, and it happens to be the case that the expected profit with short-term contracts, when you hire low ability, is the flatter one. Then we have the expected profit with long-term contract, and the one that is more steepy is the profit function of a firm of type R that hires in the market the workers using short-term contracts and always competing for the good guys. Okay, this is this disorder in the slopes. Okay, so let me tell you two variables that are a very important thing and a simplification for my argument, and then I can go to the presentation of the results. Let me call R hat the point in the interval. I will show you an interval in a moment, but let me. This R hat is the point in the interval that lets 1 minus Q workers to the left and Q to the right. Okay, it's just the point in the population of firms that is coherent with the distribution of types of characteristics of the workers, the goods and the bads. And I will call R0, that may be in my interval or not, let me call R0 the firm that is indifferent in between signing a long-term contract this firm is indifferent in between signing a long-term contract or signing a short-term contract with the specialization on hiring afterwards just the low-type workers if the juniors are very cheap. If hiring the juniors is very cheap. Very cheap in my model is paying them zero, that is, it can be zero or can be 1,000, whatever, but it's the limited liability, the minimum amount you have to pay to them by law, okay? So, is signing a long-term contract or having very cheap juniors and hiring afterwards just the bad seniors. Okay, so all the conclusions depend on the position of this R0 in the interval. Again, this is in between R lower bar and R upper bar. This is the population of firms. This is a technical parameter. It's just the R star that has here 1 minus Q, density 1 minus Q of firms, and here Q. And whether this R0 is in this part of my interval, in there or in there, is what gives me the conclusion. Okay, so let me take this case. Let me take this case and I tell you first the result. If I have time, I tell you the proof. I illustrate the proof with a figure, and I will continue. Okay. So imagine that we have this. R is here in between. So in this case, the equilibrium looks like this one. The firms that are in between R lower bar and R0 will sign short-term contracts and specialize on giving this service to the market to discover talent, but then just hiring the bad workers. The firms that are in the middle will sign long-term contracts, and the firms that are here, the ones that have more profitable projects or projects where the effort of the agent and the ability of the agent is more important. Okay, so for this firm, these firms will sign short-term contracts and then in the market compete for the best agents. So let me tell you 2 or 3 things on this figure, and then I go to the proof. Why these firms sign long-term contracts? Sometimes they are lucky and they have a good worker. Sometimes they are unlucky, they have a bad worker, but they prefer to have long-term contracts to keep these workers anyhow. Okay, these firms evaluate very much the ability of the senior because their project is very profitable. So these firms. The power, you mean the incentives? Yeah, it's like that. Yeah, yeah. So these firms will specialize in the good workers. So why these compete for the good workers is intuitive. I mean, you have a very, very profitable business. You want to have very, very productive workers. What is a little bit more complicated, more difficult to understand, but it's not very complicated, is to understand why these firms do this service to the market. Okay, and the reason is that they have projects that are not that valuable. Okay, so these firms they will prefer to have good workers than bad workers, but for them the difference is not that big. The incentive problem is not that important, and in addition, with this competition in the market for the very good workers, because the juniors know that if they, at the end of the day, they are very productive, the market will pay them a lot. They are ready to pay to the firm. They are ready to accept to work for the firm as juniors to a very low wage. Okay, so the advantage of these firms is that they are able to get the juniors trained at a very low salary. They have the juniors very, very cheap, because they are very eager to participate in this market to check the chance of whether they are good enough and go to this part of the market that will really reward them. The proof is related to this figure. This is the long-term, the expected profit as a function of R. This is the long-term expected profit when the firm signs long-term contract. This does not depend on the characteristic of the worker, because the worker will be working for the firm good or bad, because that's the nature of a long-term contract. Okay, so this is it depends on R, but this independent of the type of the agent is an expectation. Let me put, I mean, this R00 has come too soon, but this is the R0. This is the firm that is indifferent in between signing. That's the definition of R0. Okay, this is the firm that is indifferent in between signing a long-term contract and signing a short-term contract, specializing on having the bad types, but paying very, very little to the junior. And as I was telling you in one of the proofs before, this is flat, okay? And this is more steepy. Now, how big is the profit of a firm that hires a senior that is good depends on the competition on the market. If the salaries are very high, if the salaries is more steepy, that I know. If the salaries are very high, the firm will have lower profits. If the competition in the market gives salaries that are smaller, then the firm will have more profit. Okay, but this line cannot be anywhere. This line, if these are the firms that are training the juniors, and these are the firms that are freeing seniors of good quality, the set of firms that hire high ability workers has to be a particular one. And this particular one is the one that determines the utility. Okay? That's why we have this firm signing short-term contracts, this firm signing short-term contracts, this firm signing long-term contracts, and this one again, short-term contracts. One thing that is interesting, let me stay in the figure and then I go to the last figure in a moment. How much time I have? Let me stay in this figure, and then if I compare this equilibria in which there are short-term contracts and long-term contracts with this other equilibria that always exists, so there is another alternative where only long-term contracts are signed, are the firms better or worse? Are the workers better or worse? What is the conclusion? The firms for sure are better off, okay? Because if they don't like short-term contracts, they can always sign long-term contracts. So in here, for sure the firms are better off than in the other equilibria. For the workers, it is also true ex ante, okay? For the workers, this is how much, I mean, the parentheses, I don't know whether you see them, but this parenthesis is how much you get in the long-term contract, this and this, and without parentheses is with short-term contracts, okay? So with a long-term contract, a junior, with a short-term contract, the worker gets lower profits, the worker gets less, than with a long-term contract. But so if you are a junior and at the end of the day you are bad and you are signing a short-term contract, then you are worse off, okay? But if you are good, you get much more in the market because competition will reward your ability, while when you are stuck in a long-term contract, you are there and you cannot claim any improvement, okay? So ex ante, it is better off also for the workers. It is even a little bit more so that's important. This equilibrium is superior to the other one, but it's not efficient. It is not efficient means that in this model there is overuse of long-term contracts. Why? Because while even all my agents are risk neutral, in this model there is no transferable utility because I have limited liability. So if it's true that a firm will be able to generate more surplus by moving, some firms may be able to generate more surplus by moving from a long-term contract to a short-term contract, but cannot appropriate this extra profit because they cannot reduce the wages of the workers, okay? So that's another characteristic. So that's what I have to tell you. In the other cases, depending on where this R0 is, you will have, as in equilibrium, only short-term contracts, or you can have in equilibrium only long-term contracts. Okay. What's happening in here? In these mixtures in between short-term contract and long-term contract, what's the intuition? Imagine that we are in a world where all the workers are identical, okay? So there is no this mystery of whether you are a good soccer player or a bad soccer player. Everyone is equal. So if everyone is equal, there are not good players and bad players. There is no problem of who will be working with which firm. So this assignment part of my problem disappears. Okay, so this assignment part that says the good workers may be more valuable for the good firms and the less good firms don't care that much of having a bad worker, disappear, and that's the assignment part. Okay, and this assignment part is the one that was freeing my workers in the market and making that the short-term contracts have some value. So the assignment part is the one that goes in favor of short-term contracts. Imagine now that instead of having, I may have different type of agents, but I don't have a problem of incentives. I don't have moral hazard. Okay? If I don't have moral hazard, I don't need long-term contracts, because the long-term contracts were useful in order to promise to the agent more bonus tomorrow in order to motivate these agents more. Okay? So when there is no moral hazard, you can have you may have different workers, but you don't have moral hazard. Your only problem is the assignment problem, to have the best workers working for the best firms. Okay? And the combination of the two elements is what makes that sometimes short-term contracts appear more often, and other times long-term contracts appear more often or in a bigger part. What is different from the conclusion of the predetermined moral hazard problem that will say you have to sign all the time long-term contracts. So let me just finish by another thing. I was telling, but I have never explained it, that there is an interval of firms that are active in the market. In order to be active, these firms need to have positive profits. Okay, so in fact, part of the determination of the equilibria is which are the firms that are active in the market. Okay, in the model we have this element that is F. Remember, if you are a firm, if you are not successful, you get F, and if you are successful, you get F plus R. Okay, so R is the part that depends on the talent and the effort of your worker, but business as usual gives you some profit, and this is F. Okay, so the way in which we read this figure is the following. In here we have R, this part that is variable, that depends on your worker and the effort of this worker. There is a maximum R. This is just a technological condition of the market. I don't know, it can be as big as you want. And the lower bar, the last firm that enters the market, the last firm that has positive profits, depend on F. If the F part, the thing you get, whether your worker is good or bad, or whether he works hard or not, is very small, this is your R. So this is your interval of firms. Okay? As F increases, your interval of firms is larger. As F is very high, your interval of firms is higher. So there are more and more firms with smaller R that enter the market because F compensates. Okay? So this is how the figure looks, and that goes with the intuition I was telling you. When the interval of firms when the firms are very similar, all of them sign long-term contract. Why? Because they don't want to do this service to the other firms. Okay? How much you can get from the reduction of the salary of your juniors is not big enough. So when the firms are very similar, then they sign long-term contracts. When more firms begin to enter in the market, then short-term contracts begin to appear. These firms will specialize in the low-ability workers. These will sign long-term contracts. These will specialize in the high-ability worker. And when many firms enter in the market, the bigger the market is in this sense, then only short-term contracts will appear, and the equilibria, the equilibria that allows for short-term contracts to be present, will never have a subset of firms that has long-term contracts. I will just stop here in order to have some time for question or for more celebration. Happy birthday, Marilda. It's a pleasure to be here. You will be next year we will celebrate it again, but it will be 75. Okay, thank you very much.
We have time for.
We have done it for two types, but the intuition goes in the same direction. The only thing is that in equilibria, the long term, since you don't have any information ex ante about the population of workers, it will be firms that will have low, medium, then long term, and then the biggest one. And where the long term is in one part or in another will be part of the equilibrium. But this, our intuition is this one.
It seems that we always go back to soccer here. I was thinking as you were talking about the soccer, okay, and you have these long-term contracts, but clubs can sell their rights after a while. So that probably complicates the model a lot. But you see, in practice, there are special teams that are specialized in selling good players, and others that typically only sell the bad players, right? Atletico de Madrid, Barça. So does this make any? No, I mean it's a business. No,
it's a business.
Does this fit in somewhere or in possible extensions, or it's just another story? Or?
It's not in the model, but I think that another way of looking to these firms that are specialized in short-term contracts, because they are able to pay very little to the workers today, with the promise that if they are very good, the market somehow will remunerate them, can be rewritten or rethought in a way in which I pay you whatever, maybe a high salary, because if not, you never come to play with me, and if you are good, I will be giving the market this good player in exchange of being paid by him. So I think it can be read in the same way. So you are specialized in training and you do money, not because you save on the wage of the juniors, you do money because you make the other firms pay you the value of the work.
And another one, it's you talked about efficiency here, but you didn't show the result. There is a characterization of the efficient allocation.
Efficiency for in this model for us that doesn't have any social element except the profit of the firm and the utility of the workers. So if we compare
I think about a grand principle, someone that is going to organize the market in a way to try to locate better, given the asymmetric information about the type of the workers. So it may lead to more coordination and reduce the lack of efficiency you were talking before. Is that right? Or
sorry, repeat.
No, because you talked about efficiency before, no? Because this equilibrium is not efficient. So I'm a little bit...
This equilibrium is, in terms of efficiency superior to the only long-term contracts, but is not the one that maximizes overall the total profit of the firms plus the total utility of the workers.
Given the incentive constraints. Given
the incentive constraints.
Okay.
The thing you have to remove, the thing you have to reduce is the limited liability. Because that's what makes the utility non-transferable. That's what makes that the firms that are the ones that are offering the contract are not able to extract, to appropriate the surplus, so they don't do the move.
Okay, thanks.
Question? No, don't. That's it.
Thank you.
Coffee break now.
So we have coffee break, 10 minutes because we are very late. Okay, just very quick, 10 minutes.
É muito difícil, né?
Aí ele falou, não, na França também é errado. Na França também é uma coisa cultural, latina. Espanha também é assim. Não é anglo-saxão.
Mas essa soberania espanhola,
Não, eu minha deputada.
os contratos são de longo prazo e os prefeitos nós ficam passando e tocando comissário, ele não paga. Não prefeito, não paga a negócio dela.
A gente vai construindo essas instituições aos poucos,
Meu amorzinho,
a nível federal.
Daqui a pouco tá para trás. A gente anda um passo para frente, daqui a pouco um passo para trás. É isso. É simples isso. É a alma do nosso sistema político.
O câncer, na verdade.
Okay, good. Yeah, moving with the two things and my equilibrium. Have a very bad balance.
Oh dear. I just happened to move in front of the microphone. I'm not saying anything important.
Okay. I can put the water in here if you.
Yeah, but then I have to find it.
Ah, okay, okay.
Right, where is it? Where is it?
No.
I know it's there. I know it. I know.
Going back.
Okay, very good. I'm ready. Why not? Let's call him. I'm ready.
I am going to ask.
Okay. I'll try to do it really short. Yes, please. Give me a 10 minutes. 10 minutes, okay? Okay.
Okay, you want to restart again the session? The next speaker is Professor Myrna Wooders from Vanderbilt University. It's a pleasure to have you here presenting your paper for us.
Okay. So as I said before, I don't think the people out there can hear me, but I'm ready. Okay? So I'm talking about the simultaneous emergence of money in the state. This is a new subject for me. It's with a new co-author of mine also, Gail Giraud from the University of Paris one, and besides being a very talented economic theorist, mathematical economist, piano player, He also is a Jesuit priest. Okay, so he's rather busy right now. He's on a retreat. So if there's any questions with the paper that I can't answer, we'll have to wait till he's finished with his retreat. Okay, so this is, of course, in honor of Marilda Sotomayor, and most papers have keywords. Here are my keywords: game theorist, mathematician, economist, entrepreneur, organizer, friend, characterized by charm, hospitality, graciousness, and she's a leader and she's a hero. Yes, there you are, Marilda. There is my hero. Right. Okay, thank you. How about that? What is she saying? Oh, I told her in St. Paulo. Yes, but I didn't have the keywords in St. Paulo. I didn't have the keywords, right. I had the hero, but not the keywords. Okay. Okay, so this is about what constitutes money. Actually, it's a game theory applied to economic history of money. Okay? And there are multiple views of what constitutes money: demand deposits, units of account, fiat money, or the money used by the state. We're going to focus on money used by the state. Money used by the state which may or may not have a value as a commodity. Yes, it could be anything that serves the needs of the state. Our argument is that for fiat money, the state and the provision of public goods by the state occurs simultaneously. Of course, this is a rough version. We know that there's all sorts of intricacies involved, but what we do in theory, in economic theory, is we create models where we try to capture some essence of the world, right? Some essence of what goes on. In Marilda, in her matching model, she didn't really make a model of his lady and Ben, but she matched, right? And her matching kind of models characterize these kinds of matches. So we're creating a model here that's a very stylized, a toy world, right? So our view is that the state created some form of money to pay the soldiers, and the citizens were required to take the money as payment for debts and to pay taxes in these money. The soldiers could give them the money. They had to then take money because they had to pay taxes. Okay, in reality, they probably had to take the money, and they had to take the money. After all, these were soldiers who were coming and saying, "Take my money for a chicken," okay, or whatever. The ruler used the taxes collected to pay the soldiers and thus provide the public good, a security to its citizens. And to its citizens. And the elites, the rulers, did not keep too much money for themselves, because if they kept too much money for themselves, they would eventually be overturned, okay? And they wouldn't be able to provide the public good. And if you think of the public good as security, they wouldn't be able to provide security, and they would lose power. Okay, now thus money circulated and was accepted as a medium of exchange. So there are papers that talk about money and taxes, right, and the creation of money and taxes, but we add a public good and a political economy model. So we formulate the economy as an infinite horizon, political market game, and demonstrate the emergence of the money of the medium of exchange. I want to recommend to you 2 books. These are great books. Okay, they're also not a difficult read. David Graeber, Debt, the First 5,000 Years. This book was recommended to me by Jean-Charles Rocher, a very famous economist, former president of Econometric Society. So any of his recommendations are worth taking. It tells many stories of the emergence of money, and he makes fun of barter, right? Money didn't arise because of barter. I mean, talks about the various social customs and ways that groups would interact within the group and between groups to trade, right? And there's a lot of sex in the book, okay? I think you have to be at least 18 because to read it. Because it turns out that to establish friendly relationships and engage in trade with other tribes, you see, typically they would kind of exchange favors, and the favors often involved women, kind of sort of temporary exchanges, okay, on both sides. Everybody was very happy, and then the next day they would trade, okay. The other book that's very good is Douglas North. Whoops, I thought I got rid of that double S. With Wallace and Weingast, The Violence and Orders, the Social Orders. There's also an English version. Okay, actually the English version was the original, but we get you know, too often we don't recognize the originals when the originals are not English. Okay, and this also is a great book, right? It's a really great book. I'm sorry that when I was a young economist, I didn't read more about economic history. And the main references for strategic market games, because we use a strategic market game, are these papers by Amir Zahi, Shubik, and Yao, and then several papers by Dubé Giannakopoulos, Dubé Kaneko, and Shapley Shubik, who did the original market game work. But if we want to talk about a state and the emergence of money, we have to talk about what a state is. So a state is a collection of individuals typically living together in a connected area and united by common norms or a common currency and or some common laws, right? And for a state, typically, I mean, you need, or at least maybe a large population and a large state occur simultaneously. And the relationships between citizens may only be in their common citizenship. So it's not like a tribe, right? A state is not like a tribe or an extended family or a group of people who kind of all know each other or they're connected to each other. They may just meet to engage in one-shot games or few-shot games, right? And this is where really the reach of the state or the unit of exchange must extend to anonymous relationships, right? You can't rely on reputation. Okay, you know, much of the stories in Graeber's book also involve favor exchanges, right? I give you a goat today, and then when your son is getting married, and then a couple of years later when my daughter is getting married, you give me a pig, right? But you see, if people only meet once or twice, you can't go around giving them your commodities in the hope that sometime they'll be around if you need some more of what they have. So, and the state needs a way to compensate its, of course, its people for its subjects for their contributions to the necessary public goods input. They need to give people something so that they will feed the soldiers. Okay, and money is, in some sense, then a compensation under the form of a liability of the state. And the state then levies taxes paid in money, they use the money to provide the public good. So here's this quotation from Graeber's book. Why did subjects pay taxes at all? Well, of course they paid taxes. The answer seems self-evident. Governments demand taxes because they wish to get their hands on your money. Okay, this is clear. Okay, but if they become money through, then why wouldn't, just skipping a little, why wouldn't the governments just grab the control of the money, the gold and the silver mines? Then the king or the ruler or the elites would have all the money they need. So what exactly was the point of extracting the gold, stamping one's picture on it, causing it to circulate amongst one's subjects, and then demanding the subjects give it back again, right? Because that's what happens. You give them the money, and then you have to get it back. Okay. So we take a hypothetical example. The king wishes to support a standing army of 50,000 men. Under ancient or medieval conditions, feeding such a force was an enormous problem. Okay, and then I left out some. On the other hand, if one simply hands out one's coins to the soldiers and then demands that every family in the kingdom kingdom was obliged to pay one of these coins back to you, you would, in one blow, turn one entire national economy into a vast machine for the provisioning of soldiers. Since now every family, in order to get their hands on the coins, must find some way to contribute to the general effort to provide soldiers with things they want. So, so really, the money was created or brought into creation to help the king maintain an army, so he could provide the public goods, which was basically in the beginning is security, as far as we can tell. There were other monies created. Okay, the Bank of Montreal in Canada had coins, really, and means of creating money, but the Bank of Montreal didn't provide a public good. The goldsmiths had, in some sense, originated demand deposits, but they didn't provide a public good. They may have had their own private security, but no public good provided. Okay. So we want to provide, and this is what theorists do, okay, to provide conditions under which money emerges as a universal medium of exchange, and as a means of payment of taxes. Money as simultaneously, right, these means to pay transactions to pay taxes and provision of public goods cannot be disentangled. So this is an overview. I go through really the same things I've been saying. One thing I want to emphasize, in our model, we assume that people need the public good, and they need it in a sufficiently high level. Okay, so, I mean, if somebody else has a gun, and that's their kind of security, and you have a stick, you're in trouble. Okay, you know, you have to have enough public good to make a difference. Then, though, the problem is, why doesn't, of course, the politician or the ruler or the king take the money and run? And it's because if he does, then he will be replaced, and he himself will be subject to a fear of ruin, right? A fear that he himself will lose the benefits of the public good, and be likely to suffer ruin. So we look at a model, and along the equilibrium path, the politician in power does purchase public goods and pays taxes, okay, and people pay taxes. They pay taxes in our model voluntarily. They pay taxes voluntarily, okay, and we conclude that the emergence of the state money and state-provided public goods occur at the same time. Now, I want to just go back a minute to why they pay taxes voluntarily. Of course, each of us would be happy if we paid less taxes, right? We don't want to pay as much taxes as we do. But perhaps many of us, when we pay more taxes, everybody else pays more taxes, would be happy with the taxes we're paying, right? Because if everybody paid less taxes, I would be less well off, okay? And if everybody sort of deviated from paying taxes, we would be in a bad situation, as some countries have been when they don't, when there's a big underground economy and they don't collect taxes. Greece is an example, I believe, of this. Okay. As I've said, the politician cannot either use the commodities, or she can either spend the money for herself or not, but so she will want to use it to buy public goods. So we start by looking at a one-shot game, okay? Players act strategically and prices form following a market game mechanism. And that is, players take their commodities to trading posts. Prices for each commodity are determined by demand and supply. More formally, each households, and there's a trading post for every pair of commodities, so you can take apples and oranges to a trading post, right? And how many apples and how many oranges are at the trading post yes, are determined by the players, the citizens, and the price is determined by the relative abundance. If few apples are taken to the apple and orange trading post and many oranges are taken, then apples are going to be expensive in terms of oranges. Okay. The strategies of the players are the amount of each commodity to take to the trading post, and as I said, prices are determined by supply and demand. The nth commodity is called bead and may have an intrinsic value for consumption or may not. Bead could be either salt or beads or gold jewelry or seashells or whatever. And beads are then a store of value or could be a store of value and a universal medium of exchange. We assume that, did I miss a slide? No, there's transaction costs, and we also assume that the transaction costs are less than in beads, at the bead trading post, right, are less than, it's cheaper to take your apples to the bead trading post, get beads, and then buy oranges than it is to go directly to the apple-orange trading post, okay? So it's just the cheapest place to trade. Players have strategies. Of course, this, as I said, taking what they take to each trading post, and we have a Nash equilibrium. So here, one of the traders gains the ability to produce the public good. So one of the traders becomes a politician. We take it as happening randomly. Of course, in the real world, it doesn't happen randomly, but for our purpose of our model, it's something that happens randomly. We have a production function, and the utility of a player is given by the utility that he gets from his private goods plus the utility of the public good. Okay. And the starred player can buy inputs for the production of the public good, and she can raise taxes. So she sells tax receipts. She introduces a new commodity called taxes, and she sells receipts for taxes. So you pay your taxes, and you get your tax receipt. And that's the commodity that's being sold. No commodity can be traded against the taxes. You have to pay for taxes using beads. Okay, so the beads now are the money, and the taxes are appear in the form of tax receipts. The trading post of beads for tax receipts has a zero transaction cost, and the tax receipts do not enter the utility functions of anyone. So a strategy profile for most players is for every period now to take their commodities to each commodity trading post, and another trading post, a supply of beads against tax receipts. So how many beads you take and how many tax receipts you get back. And so each player then has this new strategy of how much to pay in taxes. This player, the politician, is special because she gets the tax receipts, she uses a part of them for her own consumption, and she takes the rest and uses them to produce the public good. Okay, so we put this in an infinite horizon economy in discrete time with finitely many types of long-lived households, each of them represented by a continuum. And the n+1 commodities in the public good are perishable. We could allow durable money. That would be no problem. And then we have a formal structure, which I won't bother much about. The state of nature is chosen by a Markov transition matrix with a finite set of possible states of nature. And a history is a realization of those states of nature. Now, the randomness comes in that the endowments are uncertain, right? You don't know what your endowment will be, for sure, in each period. Okay, so you get a possible different endowment at each period. That's kind of funny notation there. It looks like a typo, the exclamation mark. Ah, yes, that should be a 1. Okay. So and households are never endowed with tax receipts, right? You don't get, you can't inherit any tax receipts. or they won't be randomly given out to you, or we should hope not, right? I suppose that would be corruption. They have an expected utility. They maximize their expected utility, and with respect to commodities and with respect to the public good. So this is an important assumption. Don't bother to read it. Okay, what this assumption means is that if you have no public good, and your endowment or the amount of goods that you're allocated gets near to the boundary of the consumption set, your utility becomes arbitrarily low, right? So if you don't have a public good, you have a fear of ruin. You could suffer ruin, right? This would be like all you have left is a stick and somebody comes after you with a gun, okay? Each household, so this is the fear of ruin. Each household evaluates her expected discounted utility with respect to her own subjective probability measure, and they have their own beliefs about how likely they are to suffer ruin or what their endowment might be in the future. Okay, so this really describes the game that's going on. I know it's a little loose, but I hope you got the idea. Any kind of clarifying questions? Okay. Okay. So each citizen can potentially become a politician. I alluded to this before. And this is what politicians do. They raise money and taxes and decide on what we get for our taxes. We start the economy with the politician in power. Citizens trade according to the strategic market game each period, and the politician in power chooses what to produce. Elections are held. Citizens jointly decide whether to keep the politician or replace her with a new one. If a portion of citizens prefer to replace the politician, then the politician becomes out of office, and in this case, another citizen is chosen at random. I was looking for the button on the mic to forward this, but no, it's not on the mic. Okay. So we look for really a subgame perfect equilibrium, okay, that's renegotiation proof. So I won't go into the details of these either. So subgame perfection, I think, is a refinement that most of you know about. It's really foresighted in some sense, or looking back to see what would be the best decision. And it's renegotiation proof if there does not exist another subgame perfect equilibrium that makes all players weakly better off. Okay. Each household has their own estimate of the transition matrix, and we assume that each citizen's estimates are not too far from the truth. But we also assume that there's some dispersion of these estimates. I think that's quite reasonable, right? That there's some dispersion of the estimates of the transition matrix between different time periods. Okay. They say that you cannot get two economists to agree. Well, you certainly can't get everybody in a whole state to agree. Okay. So, yes. Then that's the second. That was the second. This is the third main assumption. Right. No individual can produce enough public good in some state, right? So for all households, eventually they're in a position where they themselves cannot produce enough public good. No individual can produce a level of public good than the required threshold in every state, right? So the public good is useless unless you can produce enough, and sooner or later, even if you're wealthy now, you're not going to be able to protect yourself in all states in the future. So here's our assumption, our main theorem, okay, and recall the assumptions. No individual can produce a level of public good higher than the threshold G in every state. Okay, so you may be rich history periods, you may be a Vanderbilt or a Rockefeller, but then your grandchildren may spend much of the money, as apparently in the Vanderbilt family they did, and then you can't buy all the security and protection for yourself. Individual beliefs are not too far from the truth. That was the second main assumption, and if the public good is less than this critical level, then individuals have fear of ruin. Now, I think this fear of ruin is a reasonable assumption, okay? Without a state, without the protection of a state or the unification of a state, the group of us together, a coalition, we're vulnerable, okay? Then our theorem says along any equilibrium path induced by a non-autarkic renegotiation-proof subgame perfect equilibrium, there exists a time such that there is no replacement of the politician after that time, and the politician makes sure that enough public good is produced. Now, you think about this, okay? So this doesn't mean that the Republican Party, for example, in the U.S. stays in power, the Democrats stay in power and forever, but we basically have one political system, right? And it's a system with elections and so on, but and the politicians may exchange favors, they may do very well, but no politician, I think, in the United States who's ever elected is really going to reduce the country to ruin, okay? They themselves and the elites who support them want a prosperous state with public good provision. Interpretation, suppose that every politician on power simply consumes all our purchases. Then from the above, each such politician will eventually lose power. After having been removed, a politician becomes again an anonymous household with somewhat incorrect beliefs. Eventually, she would end up with mistakes and end up with a consumption bundle arbitrarily close to zero, and in a situation where she may suffer ruin. And the current yes, but and if she loses power, then another politician may also come into power and or if she doesn't produce enough public good, another politician can come into power who may also not produce enough public good, and so there is still a fear of ruin. Thus, our former politicians should have accepted to produce the public good when she was in power in order to be reelected and make sure she has public good in the future. Taxes are paid, and sufficient quantity of the public good is produced. If people didn't pay taxes, right, you'd have no public good, fear of ruin, right? But as I say, the voluntarily is not that we wouldn't all like to pay less taxes, okay? You know, the IRS doesn't come to me and say, how much taxes would you like to pay this year? They say, how much will you, or here's the form, fill it out, this is what taxes you must pay, right? But as I say, I'm happy with that. In fact, if everybody would pay more taxes, if everybody else paid more taxes, I would happily myself personally pay more taxes, right? I think security and public goods are really good things in life. Right. So here's our conclusion. Citizens are willing to pay taxes and accept money as the universal medium of exchange because they need a public good. A household accepts to play the role of the somewhat, not necessarily completely benevolent government because it's safer to do so rather than incurring the risk that no public good is produced at all. And you know, politicians will always argue that they are the best people, right? The current politicians will argue that they're the best people to make sure that we have a well-functioning economy, which to some extent, means well-functioning government and well-functioning government in the well-functioning economy. And that is my last slide. And I finished in time, yes? Okay.
In advance. Thank you, Myrna. We have time for questions. Is there any question?
In this model, is there a limit to how much people are willing to pay on taxes?
The question is there a limit to how much people want to pay in taxes? Yes, right, there is. Okay, I mean the limit is determined endogenously by their preferences. Okay, so if they get enough public good, but it doesn't say, our model doesn't say how much, right? They could exceed, if they really like the public good, they could exceed the lower bound. Okay, but the utility function one can assume is concave, right, and that they will want some, but you know, unless the society is very wealthy, at least some bounded amount. Yes, David.
Sorry, yes. I think you assume that there is a share of the population that if they agree on, then they can overthrow the politician.
Yes.
Is there some way to endogenize this share, or is this something exogenous? This can, I mean...
Can we endogenize or put more detail really into the political story, right? That's basically the question. How much of the population you need to overthrow or overturn the government, or for the government to fail. That would be possible, but the model is already pretty complicated, right? With both the political game and the strategic market game in each period. I'd like to be able to do that. There was, and it escapes my mind, there was a debate by Acemoglu and Robinson about whether coalitions or groups were important also, which may relate to that. Okay. Somebody back there, a question. Okay.
Actually, just a couple of clarification questions about the model. Two things. First, the fear of ruin for the purpose of this model, is it a binary variable or a scalar variable? That, I mean, scalar, no, but I mean, it is...
Right. So it's the fear of ruin. Individuals consume bundles of commodities, but the fear of ruin is that their utility from the bundles may become arbitrarily low, may get near to minus infinity if they have only private goods and the private goods become small, right?
No, I mean in the sense of is how much fear of ruin the person have depends on how much public goods they get, or is it an on and or off state?
Ah, okay, it's on or off. It's on or off, because if you don't have, you have to have at least enough public good, one soldier with one gun, that's a minimum, okay. Or maybe 50,000 with rockets or something, missiles, okay, but you have to have that minimum really to benefit from the public good, to protect you from the fear of ruin, right? Now actually that's something else that could be perhaps more endogenous than it is, right? The fear of ruin could depend, for example, on how much of the private goods you have, or at least on your X, your private good consumption. It could be a function of, instead of just a constant level, you need at least G bar to protect you from the fear of ruin. It could be some function, right? You get more fearful as G goes down, but again, complicates the model, right? Basically, you want to make a model simple enough so that you can work with it and people can understand it, right? And complicated enough so that it reflects some reality and people don't say, well, that's obvious, right? Because you can't publish it then. Okay.
That's the ruin of researchers, by the way.
That's right.
Just a clarification. Usually when you think about public goods, you think about the free riding problem. But here
Yes.
seems to be the reversal, in the sense that there is somebody, paying the duties to be a politician, take care of the economy.
Yeah. Well, the politician here does have control of all the tax revenue.
Okay.
And the politician she chooses how much she wants to keep, right? And she wants to she wants to ensure that she's reelected, and so that she can continue to make the economy function, right? you know, of course, some politicians don't worry enough about public goods and the fear of ruin. I mean, the Tea Party would just as soon we didn't pay any taxes, but I don't think they understand that if you don't pay taxes, you're not going to get the public goods. My wealthy students at Vanderbilt, sometimes some of them think that they don't want public goods very much, right? But they definitely want people to protect their property. Okay, you know, so right, it's a public good.
Okay. Is there another question over there? Just one more.
So while the microphone I was going to get there is getting to you, I was going to say to some extent our work completes the model, right? Because people have looked at taxes before, but they haven't looked at public goods as the taxes is really based on the public goods and the necessity to provide public goods. Yes.
Oh, thank you. It's just a question of a clarification. You said if you pay more taxes, you have more public goods.
Right.
So I do not understand how it's deal with in your model if you pay more taxes and you do not have public goods.
Right.
So how it
right. So
you
this
have incorporate in your model.
Right. So this is a possibility in our model, right? So the politician, for example, may provide this critical level, but tax really heavily so that her gain to taxation is very large, right? But here we come into the notion that if a majority or if a sufficiently large fraction of the population is unsatisfied, right, and they want more public goods, they're paying more, and the government doesn't provide them, then they will eventually overturn the government, right? This is an argument that's, of course, been very popular and much relied on in some of the political economy literature, that people do become unhappy. Now, right. And of course, sometimes they have to become very unhappy, right? Willing to risk their lives, okay, to overturn governments that are corrupt, right?
Thank you very much, Myrna.
Okay,
Thank you.